Morning, guys. Good morning, people. Wake up at 5. Forget it, it's at 6. Okay, good morning, people. I see there is actually a lot of students that is not from my class. Okay. I hope this is not a surprise because all very dedicated. Okay. If you guys are from Utain's class or from Wylun's class, okay, having a 6 a.m. class, I don't think so Utain can do that. Usually Utain 6 a.m. haven't sleep. Okay, so usually if you see 6 a.m. class, it'll be me. They don't pick 6 because it's not convenient. Teacher got YouTube live ma. Yesterday I tried a live to my YouTube. I don't know why cannot connect. So I kind of lazy to connect. So then I just gonna leave it at Zoom. Okay. Then I'll post to YouTube later. Okay. But cannot wait. I did you see my just wake up hair how to post to YouTube. Hiya. But what the shit? Why got 96 people here? You're 6 a.m. no need sleep one. Huh? Just so you know. I'm not happy. Don't want to die in exam. Dedicated. Okay. Just to see you. Oh, thanks for warming my heart at a cold morning. I slept at 3. I personally, you all slept at 2. I slept at 3. Actually. So, over 100 already. Why I got more than 100 of crazy students waking up at 6 coming for chemistry. I don't know leh. Some of you from Catholic. Hello, Catholic finish exam already. Haven't slept yet. Wow, good job. Good job. Better than last time, only 10 to 30 people. Last time because I post like very last minute. So this time I post earlier. So I see what's the effect. Mana tau got more than 100 crazy people. Mantap, we try hard. Why is everyone so dedicated for chemistry? I know, right? Chemistry is so easy. Sorry. I don't want to get whacked by you guys. Okay, guys, let me prepare a bit. Sorry guys, my cat is screaming. Where's your cat? Steven, you know what I'm looking at? Because my cat sometimes a bit annoying. Is Mochi sleeping? No, he just woke up because I actually wake up so I walk around then he on the security mode. Okay, I wake up, he have to wake up. Some more later 8 a.m. you going out. Okay. I don't want to waste time already. Okay, let me try to wait. Okay, so have you all actually you all see the what's that? The notes I actually posted in that post that I actually posted. So got all the questions I actually posted inside. Let's see. Okay, so this set of paper, this set of PDF is actually meant for students who actually got their tips. So some of you actually gave me tips, right? So I actually try to get questions according to the tips. Then only I do this PDF lah. So later on when we do question now, I actually put more questions So if you can, then you just let me just put under YouTube first. Okay, so this paper is actually meant for the tips. Okay, I do according to tips one. Okay, so not leak lah, not leak. It's called tips. It's called tips. We don't use the word leak. Hiya. Some of you told me these tips I heard physics bio the tips also very detailed come out all gonna come out gonna from backside ha 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 ha. Set 1 or set 2 both. That's why I actually put a lot of, that's why there's a lot of questions. So what happened is we try to put accommodate set 1 set 2 lah. But I realized set 1 set 2 quite a lot of overlap. So we do those overlap first, then I go for the specific questions that is never overlap one. Okay, so we do those confirm come up first, like covalent bond, ionic bond, like empirical formula, and then got period table, group 1, group 17, this and all this we do the basic one first. Then later on the back at the back, right, I try to do essay, especially on drawing, because I see the tips guys, not leak tips okay. I try to do more on the essay question on the back part. So later on when you all actually come out in exam, hopefully come out in exam, I hope the tips don't scam us. How do many people wake up earlier for chemistry? 125. Okay, so let me share my screen first. Let's see. You're waking up at 6 for chemistry. Wow. I'm feeling you're very crazy. Even though I also a bit crazy, but you're lucky crazy. Anything for you. Last class only 20. Yeah, last class, because last class I didn't share to other outsiders. It's all about love. Sure. No, it's all about chemistry. Chemistry between me and you. Wow. Everyone need the tips to pass or get A. But we tell you from Malacca, so the tips don't know whether work on you or not. And some more, Vijay, you also finish exam already, right? Yeah, lo. Wow, Vijay, you all finish exam, 6 a.m. come here. Hey, all for the dedication, okay? All for the effort. Respect, preparing for SPM. Oh, good. No work tips for yeah, Malacca one cannot work here. Last time come, late come. Oh, okay. So let's see. Okay, guys, I will choose questions. Okay, don't worry because I actually posted the notes and answer together, So if you all actually got see the post, okay, on the Google Classroom post itself, right? I got post 2 PDF. One is the question, one's the answer. Okay, so actually this 6 a.m. class, if you don't come, also can one. Okay, you just do yourself and refer to answer. Okay, so this 6 a.m. class is technically just to come and see me. I want to feel good for myself. Let me say that. Okay, so there are actually quite a lot of questions here. And then I will only choose one question each topic because I need to cover especially essay. A lot of people actually mentioned to me, teacher, essay very hard. I don't know how to write essay. So I try to do more on essay. Then the front part, I just do one question each topic lah. Okay, I know I won't do myself, so you come. Wow, good to know yourself, Hi, okay. So for the first topic, okay, from 4 chapter 2, I would like to do page 2. Guys, this one, for those who actually saw this post yesterday, so if you got print, then it's better lah. If you never print, never mind. You just look at my screen and then you just write on your test pad or your notebook. Okay. So let's say for here, I'll do question 2, page 2. This from 4 chapter 2, because I see the tips the question they will ask is for cooling curve, because we prepared questions for heating curve and cooling curve. So but then as I said, I'll be selective. I just choose. So the one I choose for the first one is called cooling curve lah. Okay. So let's say for here we have a chemical called the acetite. Okay, melting point of acetite can be determined by heating the solid acetamide. until it melts as shown in the diagram on the right. The temperature of acetamide is recorded every 3 minutes when it's left to cool down at room temperature. So this is the details given, and then got the diagram given also. So what is the purpose of using water bath in this experiment? So guys, whenever we do heating curve or cooling curve, okay, so this one here is about heating first, so later on got cooling lah, okay, because later on they got cooling curve down there. Okay, so guys, here when we do heating, all heating, when we see in chapter 2, they like to immerse into water bath first. Then only they heat the water bath, then the water bath heat the chemical itself. Okay, so we don't really heat the chemical directly. Okay, what is the purpose of using water bath? Correct. For those who actually revise this already, this is a very common question. To ensure heating, uniform heating, ensure even heating, correct. Both of the keyword is acceptable. Uniform heating and even heating is the same. Okay, can I? Flammable, okay, yes, flammable also can. Okay, so of course from here, okay, so there is no lead explosion. Don't say so loud, okay, all this kind of thing, don't say so loud, even though it's true, but then we put it in an indirect way. No lab explosion. Okay, so basically is to ensure, okay, and to ensure even heating, okay, or you can ensure this keyword can change to uniform heating. Okay, even and uniform both acceptable lah. Acetamide and naphthalene both are flammable, right? Yeah. Okay, you caused small fire in lab before. What you do? Throwing matches into a test tube full of either oxygen or hydrogen. Wow, you are taking chemistry lab into the next level. Okay, so next one, bomb the school. Okay, state the name of another substance which is melting point can be also determined by using water bath as shown in the above diagram, which is, guys, usually in your exam question or maybe in your exercise, mostly when you see this topic, there are only two chemical, maybe three lah, can be acetamide, can be naphthalene, correct? Sometimes can be iodine. Okay, so iodine sometimes they can actually do the sublimation, okay, also can. So they will just go around these few chemicals. They wouldn't give you some very complicated examples. So for here, the other example will be called the naphthalene. Naphthalene. Okay, very good, naphthalene, very good. Okay, moving on. Sodium nitrate has a melting point of 310 degrees Celsius. Can the melting point of sodium nitrate be determined by using water bath? So one of the common question when they do heating, right? For water bath, they would like to ask you this. They change to another chemical that has higher melting point than the water bath. So what we know is not melting point of water bath, sorry. So we know that water bath, right, is basically having melting point of 0 degrees Celsius and boiling point at 100 degrees Celsius. Correct, because the maximum of water can go up to is technically 100, because above 100, 101, your water will boil and become gas. So it wouldn't be water bath anymore. So that's why from here, any chemical that goes above 100, you cannot use water bath anymore. So they will ask you like, what are the alternative and this and that. Maybe you're going to use oil bath, you're going to use sand bath, also can. So at here, the answer will be no, because they ask you, can the melting point of sodium nitrate be determined by using water bath? The reason is water bath maximum what? 100 so you can see melting point of sodium nitrate. Okay, melting point of sodium nitrate is higher than the maximum temperature of water, which is 100 degrees Celsius. What's the boiling point for oil bath? Oil bath usually around 250. So it means this one, you can't even use oil bath. Around there. But oil bath is around 250. So this one will be suggested to use sand bath. Sand very high. Sand can go up to 1,000, can go up to more than 1,000 also can. Sand not fun. Why? Because no kaboom. Sand is solid, isn't it? Yeah. So they just technically they just take a cup of sand and then they just stuff the test tube, the boiling tube into the middle of the sand. So the sand can also like he can dissipate heat evenly also. So it works the same. Even it's a solid, you can heat the sand bath and then sand bath can heat the boiling tube. Solid also can do that because sand is in powder form. So the powder can also pass heat in all directions. Can wrap around the test tube. Possible one. Just that you might think that sand is a solid, you think it's a bit weird. Okay, but because sand is in powder, so you can just put it in the middle. Can use sand to cook stuff? Can. That's why we have clay pot. So clay pot made of clay. So clay is technically soil. Just like sand. Just like glass pot also can. Okay. Apparatus that can tahan so high temperature. You mean the glass itself? You mean the beaker? Yeah. So the glass can. Usually the glass you all use in your laboratory is actually borosilicate glass, so the one that can go very, very high temperature. Remember some people use hot sand to bend tubes. God also. Okay, now next is one of a very, very common question. Why temperature remain constant during melting? So guys, remember when we learned heating curve and cooling curve? Okay, if you forgot heating curve is supposed to be like this. Okay, when you heat a certain chemical, the graph should go up and then suddenly constant and then suddenly go up again. So this one here is what? Okay, there's a constant temperature when you heat a certain chemical and then it will actually melt during that point. Okay, blah 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 is balanced by blah blah blah. That one, the balance by is usually cooling curve, but heating curve is actually very easy. To break force of attraction, the theory is correct, but the keyword is wrong. Cannot say break force of attraction. Correct. To overcome the force of attraction. Correct. So the keyword is overcome. Writing the word break is wrong. Okay, so that's why from here, so when we say heating curve temperature remain constant, you go too far and found superfluid. Wait, that one really too far. Okay, so what we know is, you see, when you heat until halfway, let's say if I heat maybe my phone, okay, when I heat my phone don't melt instantly, right? What happened to it is they have to absorb heat until a certain amount of energy. Only he hits the melting point of that certain chemical. So when the melting point is actually achieved, inside the particles, they were actually having enough energy to overcome the force of attraction between particles. Why need to overcome it? Because you have to remember like this, So say if it's a solid, how to draw solid particles? Usually is in orderly manner, okay, tightly packed and stuff like that. So when a solid started to melt, how a solid melt? Particles need to get further away from each other. So these are the arrangement of liquid particles. So how particles get far away? Because initially in solid, particles actually have force of attraction. They are having bonds between them. So we supply heat and the heat is used to overcome all the bonds. Okay, so you cannot say break the bonds. Why would you heat your phone? Example. You think I so rich man can heat my phone? Okay, so much physics particles. okay. So from here is so heat energy absorb. Okay, heat energy absorb. Okay, why absorb? Because we supply heat to the chemical absorb the heat. So heat energy absorb is used to overcome the forces of attraction. So I believe most of you guys can actually get this keyword, forces of attraction between particles that turns solid into liquid. So what's the keyword whenever you talk about heating curve and constant temperature? You always say overcome the forces of attraction. Okay, guys, my handwriting a bit ugly, so it's 6 in the morning, sorry. Buy a new one to heat. Wow, yo, rich. Your handwriting never changed. Sorry, Siwan. I'm just using the 6 a.m. as an excuse. It's gonna be always this ugly lah. Okay, why do we need to stir the acetamide in the boiling tube in the above experiment? So when we actually heat this chemical, so when you stir, why do we need to stir? Why don't we just leave it there and start heating it? What happened here is okay, when we actually stir and stuff, why need to stir? So temperature is even, can acceptable. Okay, so the reason why we stir is if you don't stir, the outer part of the chemical will get heat up first, correct? Then later on, the inner part will get heat up later. So I have to wait outside heat up first. Then only can inside heat up. So to make sure outside and inside heat up at the same time, heat up evenly, so we can actually stir. So we take turn to heat up, okay, at the side of the test tube. Can to make sure the acetamide temperature is uniform. Okay. If don't stir, it burns way. Heat faster, cannot. Right, heat faster, wrong. So to ensure temperature of acetamide, which is the chemical, is uniform. Okay. Yes, make sure temperature of acetamide is uniform. That one also correct. Ensure and make sure can lah. I just lazy to write make sure 2 word. I want to write ensure. Okay, so now more high class. No lah. Okay, now moving on, we have a graph of temperature against time for cooling of liquid acetamide. So now we reverse the process. Just now I was heating, now we actually cool it down. So when we cool it down, this thing goes down, and then again it has a constant temperature. Later they're gonna ask you why. Again, why here constant? Okay, so the first thing they ask, what is the freezing point of acetamide? So how to find freezing point? This one very careful, guys. Very good. Okay, because I think this graph only got one information. You all can give me the correct answer. Okay. Because sometimes if the graph gives you extra information, like what? Like they give you time, maybe this is T1, then this is T2. Then some of you will give me a teacher, freezing point, T1. Don't like that. Okay, so guys, make sure you know that freezing point is actually a temperature. So temperature means on the y-axis. So whenever you see on the y-axis and it gives you the constant temperature, that one will be your change of state. Okay, so at here is freezing point y left because liquid cool to become solid. So means this point of changing state is supposed to be your freezing point. So means at here we will say is T2. Okay, and the legendary question comes, why temperature going down cooling curve also got constant? Okay, I learned that's a mistake in first paper. Wow, Pavitra, nice. Okay, seems like you are well prepared for this chapter. Correct, guys. For this going down cooling curve, constant temperature is actually usually harder for heating curve, because heating curve, our explanation is heat absorbed is used to overcome the force of attraction, but for cooling curve, we cannot have very similar trend. Instead, they have a very complicated definition. So correct. So for going down cooling curve, the full answer will be like this. So the opposite of heat absorbed is what? Opposite of heat absorbed will be heat release. Okay. So at here, wait. Teacher, I can't hear you. Ethan cannot hear me. You all can hear me, sorry for asking stupid question. Okay. Others can hear me. Whoa. Let's see. Oh, he never clicked join other. Click. Let me guide him. Okay. Click join audio at bottom left. I think because Ethan never come online class very often. Hey, Huh? Means you try to click but cannot. From his screen, I technically his screenshot, so let me see ma. So I see the join audio. He never click ah. Wait ah. Okay, yes. Some of you giving me correct answer already. So hit. There's 4 people without audio. Oh, okay. Shit. Okay, okay. Huh? Cannot or he say he click already. Cannot have no audio. Eh. Teacher, what is T1? Okay. T1 actually, T3 and T1 actually got no specific name because it's not a constant temperature. So if it's just going down halfway, you don't have a specific name for it. Unless you start actually having constant temperature here, then that one will be having something else. But I think freezing point no more already because after solid, then no more already. Not yet. Okay. He connected some Bluetooth device because I did that once. Oh, maybe he didn't turn on volume. Okay, I try. Okay, so it seems like he having problem. Never mind. I think it's recorded, right? Recorded. Okay. Okay. So now, okay. So guys, I just move on. Okay. Sorry guys. Some of you gave me answers. I didn't actually manage to see it, but I can scroll it up. Okay. So someone said heat release by overcome the force of attraction is balanced with heat absorbed from surrounding. Cannot. That wrong already. So cannot. So the full answer is like this. So when you actually go the other way around, okay, what is the other way around? Yeah, gonna go from liquid back to solid. You have to heat release. So what happen is when you heat release, all the particles will start to form bonds. Just now is heat absorbed to overcome bond for overcome force. Now you try to think it the other way around. You heat release, just now heat absorb. Now you heat release to actually form new forces of attraction, to form new bonds. So for that's from here, the first keyword is heat loss to surrounding. Okay, heat loss to surrounding. Okay, wait. He really got no sound. Are you? He using I think some tab, Galaxy tab. He tried already. He said he turned on the volume already. He still cannot. So sad. Okay, so heat loss to surrounding is exactly balanced. Okay, balance by what? Okay, so heat loss to surrounding is giving out heat by heat release. Okay, so heat energy release as particles attract one another. So this attract one another means form new forces, form new bond. Okay. So we call them, we can say attract one another. Some of you just now give me this now, if I'm not mistaken, I see someone say heat loss surrounding is exactly balanced by heat energy released from particles to attract one another to form liquid. Okay, yes, to form liquid. Or to form liquid to solid. Okay. liquid into solid. Okay, so that's the full answer. Can write form attraction force? Can you form the new force? You form the new force of attraction. Also can acceptable. Can so that's why for cooling curve, right? The keyword got more. Okay, you have to say heat loss to surrounding is exactly balanced by heat energy release as particles attract one another. So these are all the keywords that you must write to explain cooling curve during the constant temperature for cooling curve. Okay, you see heating curve easier. Cooling curve harder one. Okay. Then what is the melting point of acetamide? So melting point of acetamide is actually again is T2. Okay. But what's the trick here? You're gonna be like, teacher, what's the difference between this F1 and G? Isn't it the same? Freezing point and melting point the same? Kind of. So technically, is to test about your understanding for freezing and melting. So did you know that freezing point and melting point, they are actually the same temperature? The difference between Q and R is whether it comes first or not. Technically, which one comes first means that what's the difference between freezing and melting? The point is the same, just that in different direction. Okay, you know why? Because freezing is from liquid to solid, then melting is solid to liquid, but it's the same temperature. Okay, correct. Yeah. Just like a toll. Okay, you go Puchong, must pay toll. Come out from Puchong, also must pay toll. So the toll amount is the same. Okay, just that different direction. Okay, so correct. Which one is different? Basically, they are changing different state lah. Okay. Then a housewife bought a mothball as insect repellent at the house. She put the mothball pieces into cupboard. Now, after a month, she found the mothball becoming smaller. Explain why the mothball becomes smaller. Because why? The moth go and eat the ball. So that's why called mothball. Evaporating. No. Evaporate is liquid, become gas. But this one mothball is solid and become gas. Ask the housewife. Mochi, play with it. Wow, your creative answer. Correct, guys. Because right now you're having solid turning into gas straight away. We call that process sublimation. So we can say mothball has sublimated. So the keyword here is called sublimated and becomes smaller in size. Becomes smaller. Not evaporation, no. Evaporation, liquid to solid. Okay, so after question 2, I will want to do the next one. Next page, page number 3, which is next page. This one. Okay, next one, we have the elements here. We have P, Q, U, R, S, T, V, W. Okay, there's a lot of elements here. So arrange. Accidentally slap off. Can you get the recorded version? Can. I will post it onto YouTube. Just try to find. I'll post a YouTube link into Google Classroom also lah. Some of you fall asleep. It's okay. It's 6 a.m. in the morning, guys. I understand. Okay. So arrange the elements in ascending order of atomic size. Okay, so guys, to determine the size, first of all, how to know which one bigger in size? If I go according to different period, so if you know, okay, what period 1, period 2, period 3, 4, and 5, if I go by period, let's say if I compare R and V, who is supposed to be bigger in size? V. Why V bigger? Because R is period 3, he only got 3 shell. But then V is period 4, then he got 4 shell. So because number of period that determines your number of shell. So the more period you go down, the more shells he has. Okay. So from here we have R. Let's say if you compare R and V, V is supposed to be the bigger shell, the bigger size lah, because you got four shell. Okay. So I would say going by period is easy, but among the period, okay, means in that period. Let's say if I compare P and Q, who's supposed to be bigger in size? Someone say P, someone say Q. Okay. So the answer is actually P. Why? Why P? Why not Q? Because if you think about it, you see, let's say P and Q, they are in period number 2. Correct? P and Q is period number 2, right? Technically, P and Q, they both supposed to have only shell. Then they both have same number of shell. Isn't it they supposed to be the same size? No. Why? Because when going across the period, very good number of proton is the changes. Because when going across period, you know, when you arrange periodic table, they are arranged by proton number. So when you go across the period, proton number increase. For example, let's say if I count the proton number, this will be 1, this will be 2, 3, 4, 5, 6, 7, and 8. So you see, P got 6 proton, Q got 8 proton. So by having more proton, how he changed size? Imagine, I told you, where's proton? Proton is usually inside the nucleus. Correct. Okay, wait, let me write this. He cannot let he restart his iPad. I mean his Galaxy Tab also cannot. I asked him go sleep. He changed phone also cannot. He told me that he used his phone also cannot. He should take recorded. I know, right? I know, no choice already lah. Okay, back to here. So 6 proton and 8 proton. So you see, if you got more proton, imagine guys, why I say more proton affect your size? Because if you draw the arrangement of an atom, okay, from here you see, so you know that this is the nucleus. Okay, then if you got 8 proton, it should be supposed to be 2.6. Then P is 6 proton, supposed to be 2.4. Correct. So if you draw it out, so 2.6, that is 2.6, 1, 2, 3, 4, 5, 6. Then here is 2.4, 2.4, 1, 2, 3, 4. So the outside one is actually what? The electron. So if you got more proton, means imagine like you're having more magnets. Okay, you're having, because why do I say more magnet? Because who is attracting electron? Is the proton in the nucleus. So the more proton you have, the stronger force to attract electrons. So if you got stronger force to attract electron can be pulled closer. You understand the concept? Okay, so technically among the same group, means like in the same group, the most right hand side supposed to be the smaller in size. Okay. How to remember charge in periodic table? Charge is determined by the number of electrons he donate or gain. So usually, let's say for group 1, it's all positive charge. Why? Because it's 2.1, 2.8.1, 2.8.8.1. They all donate 1 electron. It's positive charge. So if it's group 2, it's positive 2. Okay, like Mg2 plus, okay, Ca2 plus, okay, because why? They donate 2 electrons. So the number of charge is determined by how many electrons he donate and how many electrons he gain. So that's the concept for the number of charge. Okay, but for here, guys, let me come back to here. What is the ascending order for atomic size? So who's supposed to be the smallest? Because I want to go ascending. Ascending means from the smallest one to the biggest one. Who is smallest one? Okay, which one? I should find the one with the least shell, which is here, I think, period 2. Okay, the least shell is period 2. Okay, then at the same period, I should start from the right hand side because he got the most proton, he got the strongest force, he will get attracted, electron will get attracted closer to the nucleus. He's supposed to be a smaller size. So it goes from U, and then U, then followed by Q, followed by P. So U, Q, P, then only you move on to the next period, which is T, S, R, and then W, V. Okay? You all understand how to arrange from here? Okay, anyone don't understand, please don't be shy to ask, okay? Can so everything, if you want to arrange in size, go from the smallest, the least number of shell. So at here, I think minimum is 2 shell in here. Okay, 2 shell. So then in the same period too, start from right hand side because that one will be a smaller size. Okay. Next one. It's about electronegativity. Okay. What is electronegativity? I think some of you never focus on this part lah. Okay. So technically, electronegativity is tendency to do what? Tendency to gain electron. Tendency to accept electron. Correct. Okay. To attract electron. Very good. Very good. So what happened here is usually we can compare, you have to ask you to compare two elements. So I got R and T. So if you compare R and T, who is more likely to receive or gain or attract electron? So if I ask a very simple question, R is 2.8.1, then T is 2.8.7. Who more likely to gain electron? Obviously, it's the 7 one, no? Kind of. So the answer here supposed to be element T. Element T. Okay, what's the concept from it? Because this I told you that it's about the arrangement, so 281, this one is 287. Okay, so element T has a higher number of protons and positive charge of nucleus than element R. Okay, so write element T or atom T. Follow the question. If the question gives you element, write element. They give you atom, write atom. This is a very tricky one. Okay. So from here, we should say follow question. If question they'll give, better write atom. Okay, but I will say usually atom is the best answer. But because this question gives you element, so just to be safe, we will write element. Okay. Can you explain electronegativity again? Okay, come, write down here. Electronegativity is tendency to attract, or you can say gain electron. Means who is more likely to gain electron. You get the point? So why this one more likely to gain electron? Because he got 2.8.1, he got 11 proton. Then this one got 2.87, he got 17 proton. So who got more positive charge? Then he'll be more higher tendency to gain electron. Okay, would it be better at conducting electricity through the question? I thought is the question. Better in conducting electricity? Not really. Not really. To donate electron, is there electropositivity? Yes, the opposite of electronegativity is electropositivity, tendency to donate electron. So I will say R is high electropositivity, electropositive. Then T is high electronegative. But now they're asking in terms of electronegative. They never ask about electropositive. So in terms of electronegative, T is better. R is not good in terms of gain electron. Go on. Got electronegative and got electropositive. Okay, so besides talking about proton and positive charge, the next keyword is, we also learned just now. Yeah, let me use it, same color. Element T has smaller atomic size than element R. Comparing R and V, that means V is more electropositive. Yes, if you compare R and V, V is more electropositive. That's the assumption. If teacher asking you to compare electropositive, then V is more electropositive. Correct. Higher tendency to donate electron. Okay, and then technically these two is a keyword already. So the conclusion will be element T. Element T has stronger force to attract electrons than element R. then we know it's actually more electronegative. Sorry guys, I heard my room upstairs got some stuff dropping. I think it's my cat. Assassin. Your school teacher say this kind of question should use atom T instead of element T. Yeah. That's why I say usually if question never say anything, use atom is a safer answer. But because question here use element, so we follow the question. Okay, if you say teacher, what if I put atom? Actually, atom confirm correct one. Atom is the best answer. Ethan finally settled. Ethan finally can hear me. Hiya. It's okay, Ethan. The front part you can watch video. Okay. And so okay, moving on. How does the atomic size changes when going across period from left to right? So actually just now we explained this already. The size go from left to right in the same period. Let's say from V and W from left to right, supposed to be becoming bigger or becoming smaller? Decreases, correct. Smaller. Okay, but why? Explain your answer. Okay, again, it's about the proton number. Okay, so because going across period, the number of shell is the same. So V got 4 shell. W also got 4 shell. Everyone same period, actually same number of shell. The thing is the proton number is different. So when you have different proton number, so we can say when going across the period, okay, when going across the period, proton number increase causes the positive charge to increase. Okay, so when positive charge increase, we know that strength of nucleus to attract electron becomes stronger. So when you have stronger force, stronger strength to attract electron, we know that electrons are pulled closer towards the nucleus. Okay, so when the electrons are pulled closer towards nucleus, the size becomes smaller. So atomic size decreases across period from left to right. Okay, moving on. Give one special characteristic of W. Do you see W is actually placed in the middle of the periodic table? What is it considered as? Because in periodic table we learn 5 topics. What are the 5 topics we learn in periodic table? Group 1, Group 17, Group 18, and then we got period 3 and transition element. Okay, so we in total got 5 topics lah. So if you go into the notes, right, in general we got 5 topics. So at here W is in the middle. It's actually the last topic. So we know that W is supposed to be a transition element, transition metal also can. But they want one special characteristic. How many special characteristics of transition element have? 5, 4, 5, 4. Got 4. Okay. So what's the 4 special characteristic? Can be used as a catalyst, correct? Okay. Form colored ion, very good. Form complex ion, very good. What's the last one? More than one oxidation number, very good. So you can actually have more than one type of oxidation number. Oxidation number means different charge. Like Fe can be 2 plus, can be 3 plus. Okay. So this is because he's a transition element. Okay. So from here, you can see here, can act as catalyst. That's number 1. Okay, just to remind and refresh you guys, let me put all the answers here. You can say can form colored ion, okay, and then form complex ion, And lastly, has more than one oxidation number. Okay, why I give you all? Because sometimes question not so good one. Okay, they might ask you to list 4 special characteristics. Then you only memorize one, the GG. Okay. Okay. Teacher need to leave early. Thank you for your class. Useful. Oh, so early. Okay. Wow, you are some days so productive, one, I thought at first Sunday 6 a.m. you all got nothing to do. Okay, it's okay, it's okay. I'll post the rest into YouTube, then you can watch it the rest. You can watch the rest. You cannot sleep already. Hey, leave early to sleep. Bye 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 bye. Okay. Which element is monoatomic? Okay, we're gonna use the symbol on the top. Will I upload the video today? Yeah, after class I'll upload. Because tomorrow exam, if I upload later, no point. Okay, don't worry, I upload. I use dual. Just saying. Okay, so who is monoatomic? Monoatomic is what? Monoatomic means that this atom, okay, he can be alone and stable. So what is the group that can be alone and stable at the same time? Very good, group 18, which is noble gas. So which element is group 18? U. Okay, you are. So okay, and then who is diatomic? Diatomic means that they like to come out as a pair. And a pair usually is what? A gas and is a non-metal. So what group like to be diatomic? Group 16, group 17. Can. 16, 17 also can. But I think I here only got 16, 17. No. So Q or T also can. Okay, Q or T also can. Okay, so from here, you put T lah. T is the safe answer. P, P cannot. P cannot. P cannot. Sometimes can, sometimes cannot, because P is at the middle of the periodic table. Sometimes some of it is semi-metal. Can diatomic, but sometimes also can be monoatomic. So it depends. If it's a metal, then can be monoatomic. Okay. Used to increase rate of reaction, guys. How do we increase rate of reaction? By adding catalyst. So who's the catalyst? This time we found the answer. W. The transition element. Who can react with cold water? Usually chemical quite hard to react with cold water because they are not very reactive. But we learn a group that is known as reactive metal. What group is reactive metal? Correct. Group 1. The one, the sodium, potassium, lithium, sodium, potassium, the one that we throw inside Taman Jaya. Okay, the one we throw inside water and give you explosion one. Okay, so from here is your R or V. Okay, so RV, okay lah. Yeah, form M4 ferric oxide. Who is M4 ferric? Correct. Okay, as this one very special. M4 ferric usually is aluminium. So where is aluminium? Check your periodic table. Because usually exam, some more is government paper. Confirm they give you periodic table one. Okay, so aluminium supposed to be element S. Correct. Group 13. Okay. Turn blue litmus paper red and then white. So blue to red is what properties? Blue to red is acid. Then the red to white, why got red to white? Correct. Red to white, it's bleaching properties. So what chemical give you acid then bleach? Okay. But did you say paper 1 won't have periodic table? Paper 1, the objective question, no periodic table. So sad. So lithium, sodium, all which group? Group 1. Group 1. Okay. SPM got what? You mean periodic table? Got. Confirm got. Okay. Can explain bleaching? Okay, let me explain bleaching a little bit more. Let's see. Okay, so the answer here is supposed to be the only one group that gives you bleaching properties is group 17. This one fixed already. Fixed answer. Okay, so means who is my group 17? Let me put it in first. Group 17 is element T. Okay, atom T, okay, let me explain the bleaching properties. Okay, so let's say for T, technically I would say the first 3 elements in group 17 can give you bleaching properties. For example, this one, let's say for T is actually chlorine gas, okay, Cl2. How to get you bleaching properties and the acidic properties is we take your halogen, group 17, we add with water, we plus water. So when we plus water, what happened to it? It will actually combine and form 2 chemicals. How to form the chemical? Okay, if you guys remember, inside water actually got 2 ions inside. What's the 2 ions inside water? Inside water got H plus and OH minus, got 2. So that's why the Cl here will combine with 2 of them. So one gives you HCl, which is hydrochloric acid, acidic. Then the other one is the OH and the Cl combines to form HOCl. And this we know is hydrochloric acid, hydrochloric acid. Okay, but the next one, the HO, is called the hypochlorous acid. So this is the bleaching properties. This one, the HOCl, this is bleaching. This is bleach. Okay. That's why if you actually accidentally inhale chlorine gas into your lungs, Cl2 goes in, your lungs got water, so it will form hydrochloric acid and then also got bleaching agent. Means your lungs will start to corrode and become white color. okay. Can call bleaching agent? We can call it bleaching agent. Okay, it works on fluorine also. It works on fluorine, chlorine, bromine also can. But iodine supposed to also have. But then because iodine is very low reactivity, so it kind of not very obvious results. Okay, technically the whole group 17 can form bleaching agent, but the last one, iodine, is so low reactivity, it doesn't really show you the white color. Wow, I got birds chirping here already. Wow, we are earlier than the birds. Just now 6 a.m. no bird. Now 7 a.m. got bird. We better than bird. Where you live? You heard that too, Hello, bird everywhere, You think I live beside you, meh? I live at Kota Kemuning. USJ people, different bird. My one is rooster. Your house got rooster, My area a bit hard to have rooster, If got, he's gonna be my dinner already. Hey, sorry. Okay, next one. So why you so good? Wake up and teach at 6. Not I good, Tomorrow exam, And today the whole day I got no time already. So I have to do on 6. Okay. So next one, guys. Element R and V are actually in the same group. Which element is more reactive? Here comes the reactivity. Okay. So I see you no more to sleep already. Whoa, don't like that. Later after I finish this class, I can go sleep. I will sleep again. You should do tomorrow 3 to 5. Then you go exam with a sleepy face, is it? Okay, guys, talking about reactivity, reactivity on group 1 and group 17 is very important. Okay, either one. So we purposely put 2 things here, you see. One is for group 1, one is for group 17. We do both. Okay, we do both just in case. Okay, so why group 1? Okay, let's say R and V. Okay, R and V is in group 1. So who is more reactive? Is R more reactive or V more reactive? Actually, just now some of you asked me already about the electropositivity. Actually, electropositivity is the reactivity. So it also, even if you don't go to electropositivity, you ask yourself on top in terms of the electron arrangement. So R is 2.8.1. Then what's V? What's the electron arrangement for V? If you see this is period 4, it's supposed to be 2.8.8.1. So if you ask yourself, this one 3 shell, this one 4 shell, the 1 electron at 3 shell and 4 shell, which one is easier to donate? Because reactivity depends on the tendency or maybe the accessibility for that thing to actually do his job. So at group 1, the thing they want to do is donate electron because it's one valence electron. So every element in group 1 want to donate electron. So who is easier to donate electron? The one that is further from nucleus. So the answer should be V lah. Okay. But of course, how to put it into marks? Because they say explain, usually this question can go up to 5 marks. So if you say, oh, because V is more reactive, cannot like that one. So V is more reactive, can 1 mark. Okay. But what are the further explanation can get up to 5 marks? So number 1, okay, we say that element V is your answer lah. Element V. Okay. Element V is the first mark. But why? So first thing we know, R is 3 shell, V is 4 shell. So we write that first. Okay, so atom V has larger atomic size than atom R. Okay, so correct. So if the atom is bigger in size, what's the next hint? What's the next point? So this is 3 shell. So electron like this. Okay, then if it's 4 shell, electron like this. So what's the difference? It's the distance between the nucleus and the valence electron. Correct. Okay, the next keyword is distance. So the single valence electron, okay, the single valence electron is further from nucleus in atom V. Okay, or you can say distance becomes further. Okay, you can say distance between nucleus and valence electron is further away. Also can. The sentence got no fixed structure, just to write in the same meaning. Okay, so I write single valence electron is further from nucleus in atom V. So when the distance is further, when you and your girlfriend very far away, you at Malaysia, your girlfriend at Singapore, long distance relationship, is it actually a strong force? We talk about force because some Ian say that after single valence electron distance further, you say easier to donate. Before easier to donate, you have to mention about the force of attraction. So when you actually very far away, your force of attraction is actually weak. Correct. So you can say force of attraction. Okay, but then you have to write in detail. Force of attraction is weaker, correct? But force of attraction between who? Me and you, may. Okay, so from here, force of attraction between nucleus and valence electron is weaker in atom V. Okay, so when the force is weaker, then your answer comes into play. Easier to donate. And donate to do what? Achieve stable. For here, 2.8.1, 2.8.8.1, once they donate, they all become stable octet. Remember the keyword octet? Okay, so we can say it is easier for atom V to donate the single valence electron to achieve, okay guys, I got no space, achieve stable octet electron arrangement. Those who are my students, you know what I'm gonna do lah. Achieve stable octet electron arrangement. Okay guys, okay lah, don't want lah. Okay, here got a lot of other teachers, students later you all say I'm very lazy. Achieve stable octet electron arrangement. Yeah, no space. They don't know you lazy, mate. They don't know ma. They don't know me. They first time see me here, maybe. Okay, guys, this is group 1. But if you go for group 17, what's the difference? Will it be the same trend? Will it be the same keyword? Definitely no, ma. Why? Because group 17, group 17 do what? Group 17 got what trend to do? So this is how I told you the analysis is group 1 try to donate electron. That's why we look at the one that is easier to donate. So it's more reactive. Okay. Then group 17 not going to donate anymore. Group 17 do what? Try to gain electron. So if I ask you one thing here, yeah, they say Z is below T. So Z supposed to be here. Yeah, I remove this. Okay, so Z supposed to be below T. So T is 2.8.7. Z is 2.8.8.7. Okay, so now 7 valence electron means they try to gain electron, receive electron. Who is easier to receive? Who then the one will be the more reactive one. So how to determine easier or harder to receive? Again, determine by what? By the distance of nucleus. Who nearer to nucleus, then you have stronger force. Then stronger force, then give you easier to receive, easier to gain electron. Okay now. Okay, you nearer to your crush, you nearer to your idol. Easier to actually get relationship kind of. Okay. So from here, same thing here. How to know distance? Technically, the shell actually determines out. So got 3 shell, got 4 shell. 3 shell nearer to nucleus, then he'll be easier to gain electron. Then element T is supposed to be the more reactive one. Okay. So you see a trend. Group 1 going down more reactive. But group 17 going up more reactive. You see the difference in trend? Group 1 go down more reactive, but group 17 go up more reactive. Okay, can so you all get the big idea about it. So if okay, let's try the answer here. So we can say that which element is less reactive? They're asking for less reactive, not asking for more reactive. So Z and T, who is less reactive? So would they only ask group 1 and group 17 for reactivity? Yes. Reactivity only group 1 and group 17. No other group already. Because you learn group 1, group 17, and group 18. 18 got no reactivity. 18 is all stable. So only group 1 and group 17 got reactivity. Okay. So we can see. So who's less reactive? Definitely is element Z. So element Z, okay, is less reactive than element T. So, but why? So again, guys, the trend is the same, but keyword different. The trend is number 1, size, number 2, distance, number 3, force. Okay, so we say that atom Z has larger atomic size than atom T. Okay, so if bigger size, further distance. Okay, so we can say, but then the distance you have to say between two things. Just now, group 1 is distance between valence electron and nucleus. So for group 17, you're not trying to donate electron, you're trying to gain electron. So you should have to say the distance between nucleus and the outermost shell, the last shell. Okay. So we can say distance between nucleus and outermost shell is further in atom Z. So when distance further, easier or harder to attract? Or we have to talk about the force first, okay? Or maybe the strength also can. Force and strength is the same thing. So we can say that strength, so actually I use a different way. So I give you guys a design. So strength of nucleus to attract electron in atom Z is weaker than atom T. So when the strength to attract electron is weaker, so you will say that it is harder for atom Z to attract electron into outermost shell to achieve stable octet electron arrangement. The reactivity here is talking about reactivity of donate or reactivity to receive, depend on the group. Group 1 is, okay, group 1 reactivity depend on tendency to donate electron. So who easier to donate, who is more reactive. Okay, then group 17 is the balik, because group 17 is trying to gain electron. Who easier to gain, then who is more reactive. But the point is, if you go comparing by going down the group, going down group 1 supposed to be more reactive because going down is easier to donate. But group 17, going down is less reactive because going down group 17 is harder to gain electron. You get the difference in trend. Okay, so reactivity on group 1 and group 17 are two different things. The trend is different because group 1 trying to gain, group 1 trying to donate electron, group 17 trying to gain electron. The action they want to do is different. That's why reactivity is two ways on different group. So this one will be a full answer for essay question. Okay, this one possible to comment essay. Not T weaker to gain electron. No. T lesser shell. Lesser shell means nearer. T is above, correct. If you check, they say Z is below T in group 17. So in group 17, going down, getting less reactive. Why? Because it is harder to attract electron if you go down group 17. Okay, so that's why I always tell my students, guys, group 1, group 17 must be very clear on what's the difference. Because most of you guys think it's supposed to be, your think it's the same explanation, then wrong already. 1 and 17, totally two different things. Basically, the one that can donate or attract easily is more reactive. Yes. If you want to conclude it in this way, who easier to donate or who easier to attract is the more reactive one. Okay. But going down group might confuse you. So you have to depend on the number of shell. Okay. The one that is easier to donate or easier to attract is more reactive. But who easier to donate, who easier to attract depends on the number of shell, depends on the force. Okay, that's the depending variables. Okay, so next one, let me see. Next one is okay. After this one, I want to do one question on empirical formula. So when you want to do chapter 5, actually chapter 5 I plan to do on essay because I see the tips chapter 5 essay. So I got essay question at the back. I finished the empirical formula first, then I do chapter 5. Okay, can okay, so empirical formula question, I choose one to do okay, this one. Question page number 5. Page 5 page 6. Page 5 pula. Page 6 Okay, so guys, when we go for empirical formula, actually empirical formula got two experiments. One is on page 5, this one, the magnesium powder, you heat it with direct oxygen, okay, but you have to open and close the lid. The second experiment is the harder one, okay, is copper oxide heating with hydrogen gas, okay. So because what happened here is, this one is harder because here is CuO, but what is happening here? Here, hydrochloric acid plus zinc is actually happening here. So hydrochloric acid, if you plus zinc, what happens is zinc will kick off the H. So when the zinc kick off the H, it becomes zinc chloride and hydrogen gas. So the gas, when you form here, the gas will flow up inside here. So the H2 comes here. Then the H2 will only react with the copper 2 oxide to give you a reaction. So what happened here? Here is copper oxide plus H2. Do the same thing. H2 snatch the oxygen, snatch the girlfriend, become H2O plus Cu. Okay, so what we really want to do is this one. Okay, the one at the bottom here is just a preparation of H2. Okay, the chemical we use at hydrochloric acid and zinc is just to prepare H2, and the H2 is the one that we need to use to react with copper oxide. Okay, just to clarify what happens here. At the left side here is like nothing just to let the extra H2 flow and dissolve into water. Nothing much. Okay, it's just a safety precaution. Okay, what is meant by empirical formula? So empirical formula, I hope you all remember. Okay, is the what? Is the chemical formula. Okay, this one always asks, chemical formula that shows what? The simplest ratio, the keyword. Okay, I will say this one, simplest whole number ratio of atoms for each element in a compound. Okay, so this is the full definition for empirical formula. Okay, simplest ratio of atom of each element in a compound. Must put in a compound. Never put in a compound, no mark. Very strict on this. How teacher remember? I teach you. You take a test pad, you write 100 times. Confirm remember. Can one, slowly. Don't cry, don't cry. Not practical. Can one. The Kisiao method. Okay, you all come at 6 a.m. class, you all memang crazy. What's more crazy on having class on 6 a.m.? Okay, so moving on. How do you dry the hydrogen gas? Okay, so having class in 3 a.m. sorry. Usually 3 a.m. I haven't sleep. Having YouTube live at 3 a.m. Boy, you all don't crazy cannot. Okay, so for this one, guys, this question usually is applicable on the O diagram. Okay, Liang Jie did that before. Is it at 3? Don't know. 3 I haven't sleep. I need my sleep. Okay, how do you dry hydrogen gas? This diagram not supposed to actually have this question, but this question is the one on the O format, on the O diagram. They usually have a U-tube, a U-shaped tube, not the YouTube you all watch, a U-shaped tube that contains a certain chemical to dry the hydrogen gas. Because last time before this diagram come out, because before this setup, they used to have a more complicated setup, and the complicated setup need to dry the hydrogen gas. Here we don't care. Here how we dry is actually just burning it. Okay, we just don't care about the drying anymore. Okay, the anhydrous something, right? Yeah, correct. It's called the, okay, you flow the hydrogen gas through a special chemical called the anhydrous calcium chloride. Okay, it's calcium chloride. Calcium carbonate can guys. Calcium chloride also can, calcium carbonate also can. Use tissue paper, cannot. Filter paper, cannot. Must be anhydrous something, because the point is the anhydrous. Anhydrous means the chemical got no water. He's desperate for water. He very dry, like you all. Just kidding. No, nah. How about H2SO4? Can also. But H2SO4 is in liquid. So it's also can. H2SO4 like to also absorb water. Not bad. English class also can open car. Okay. What is the purpose of using zinc granule and hydrochloric acid in this activity? So I mentioned to you, why do we need this step? It's not our actual experiment. We need this to produce the H2. So technically, to produce the hydrogen gas. to produce hydrogen gas. Okay, write a chemical equation for the reaction. I gave you the answer, but I haven't balanced, guys. Equation writing already, come here, come starting already. So hydrochloric acid plus zinc, you get zinc chloride plus hydrogen gas. Balance equation, 2 in front of HCl. Oh no, my coffee no more already. Okay, what changes can be seen after the copper of oxide is heated strongly? Guys. Okay, why did I start talking Chinese? Suddenly my brain cannot adjust my language. Shit. Chinese also can. No, I need to accommodate non-Chinese also. No coffee, no brain. The moment I finish my coffee, I feel like I'm out of drugs. Okay. So oxide of copper, guys, what is the color for copper 2 oxide? This one, test your form 4 chapter 6, your acid, base, and salt. Green, no. Blue, no. Because copper 2 is the one that is very tricky. He can be 3 colors. Very good. Most of you guys give me answer is black. The very, sorry, no, I don't racist. Sorry. Okay. So, okay, now, okay, just to let you all know, okay, who is blue color? Because I see some of you giving blue color. Blue is actually not wrong because the common color for Cu2 plus is blue. Okay, common color for Cu2 plus is blue. Okay, but then copper 2 plus can be different color when he mix with different different chemical. So CuO is the black. Is black. Okay, then CuCO3 is green. Okay, so there are 3 different colors for Cu. So CuSO4, CuCl2. Okay, anything else from this is blue color. Means CuSO4 blue, CuCl2 blue. Okay, CuOH blue. But CuO is black. CuCO3 is green. Make sure your memories so I see some of you gave me blue and green. Now you know. So the original color of copper 2 oxide is black. Okay, CuCl2 is blue. CuCl2 is blue. Means anything else from here. Okay, if not this, then it's blue. So what time the class finish? I supposed to finish at 8, but I see my progress a bit slow. So I might extend. So those who need to actually go want to leave for church duties and stuff, it's okay. Okay, I will just continue to. Those who need to leave, it's okay. Those who want to sleep, also okay. I okay one, okay. When you wake up, or maybe when you are free, just watch the video. Okay. So early go church. I got one student tell me, teacher, I got church duty. I cannot understand. Okay, I didn't know class ends at 8. Is it? Now you know, but not. I think I can extend lah. Don't worry about that. Okay, so okay, then means from here you got food duty. Okay, will you revise chapter 7? Chapter 7 after chapter 5, because chapter 5, chapter 7 quite important in the tips. Then chapter 6, I think a bit not very important. Okay, so guys, I think you also have to do your own effort. I cannot do everything in one day. Okay. Just now kena neck to attend 6 AM class. Why? Come for class also need to kena neck. Chapter 6 not important. I mean for the tips for the coming exam. Okay, for the coming exam, acid and base, not very big portion. Not very big portion. So I try my best to cover chapter 3, 4, 5, 7. Okay, and then you all try to revise yourself for 6 and 8 lah. Hopefully, like this is my plan lah. Chapter 6 big topic there, yeah lah. Because if I do chapter 6 at here, I think we're gonna go all the way until 6 PM. Wait, 6 AM to 6 PM, is it? You study chapter 6 like shit. Okay, later I try. Okay, then we don't waste time. Really, come. Okay, so the original color for copper oxide is supposed to be black, and it's a black solid. Okay, but this black solid turns into where? Turn to what color? It turns into, if you look at the equation, CuO after being snatched girlfriend becomes Cu ma, kind of. So Cu is what color? Blue. No. You know why? Because all these is because they are having Cu2 plus, Cu2 plus, Cu2 plus. That's why you got blue, you got black, you got green ma. But now, after the reaction, your CuO becomes Cu. No charge. Copper without charge is copper metal. What is copper metal? The one you see in your copper wire. If you don't believe, now take your phone cable, cut open, see inside what's the color of copper. Don't cut your phone cable. Wait, just kidding. So correct, guys. Gold color. Wow. Your cable got different story. So technically, guys, the answer here is turns brown. Okay, because copper solid is brown. Okay, so you see copper got many color. Copper 2 plus is blue, but copper 2 plus can be black when combined with oxygen. Copper 2 plus can be green when combined with carbonate. But copper no charge is brown. So copper very fun one, many colors. Okay, so guys, the next one, the calculation. Okay, what happened here is, you see, we have all the values here. We have all the mass of the tube, the paper, the copper, and the mass together with the oxide of copper. So if you only want the mass of copper, how do you want to find? Let's say if I label this 1, 2, 3. To find mass of copper is what minus what? Add maths time. This one is not even add maths, bro. This one is simple maths. Correct, guys. 2 minus 1. Okay, I just draft, guys. But how to find mass of oxygen? I want oxygen only. Oxygen only. Means you should minus off the mass of copper also. Correct. So it's 3 minus 2. Okay, so the calculation, guys, you all just do. Okay, how to do the next part? How to find number of mole? In total, how many number of mole we have? Formula. What's the formula of number of mole we have in total? If including chapter 6, the acid, base, and salt, okay, in chapter 6, we total got 4 number of mole formula. What are the 4 number of mole formula? Come, just to refresh you guys a bit. Number of mole can be number of particle over Avogadro constant, not avocado. Number 2, we got mass over molar mass. Number 3, we got volume over molar volume. Number 4, we got MV over 1000. Okay. Okay, got squirrel in your front yard. Wow, your one lagi ting chow. My one got bird, your got squirrel. Okay, so what happened is, guys, at here we're supposed to use which one? The question give you mass, and then do you see question also got give you atomic mass? Atomic mass technically is molar mass, so we can actually use formula number 2. Okay, so you can just use this formula. So mass over molar mass. Okay, guys, you all just simple calculation you all just do, and then you're supposed to get your ratio is this one 0.2, this one 0.2. Okay, I'll give you the answer straight away. I don't waste time already. Okay, the point is, after the number of mole, how to convert into ratio? After you found number of mole, what's next to convert into ratio? So if it's the same number, it's supposed to be very simple. If same number means 1 to 1, but if it's different number, how? If maybe one side is 0.2, the other side is 0.3, how? Then you're supposed to divide both sides with the smaller number of mole. Yeah, correct. Divide the smaller number of mole. So it means here 0.2 divide 0.2, you get 1. Then 0.2 divide 0.2, you'll get 1. So the ratio 1 to 1, your empirical formula is CuO. Okay, 1 Cu, 1 O. Balance equation, I gave you the answer already. So CuO plus hydrogen gas, snatch girlfriend becomes Cu plus H2O. This one is already even balanced. No need to balance. Okay, there are some precautions that question like to ask. Why the hydrogen gas need to flow continuously before the heating process? Means before you start heating the chemical, you have to flow H2 for continuous, maybe for 5 minutes like that. Why even before we start the reaction, we need to flow H2 into it? Because the concept behind here, to dry it, no. Okay, the concept at here is if you don't do that, means in your tube right here, okay, this tube here, this tube supposed to have oxygen because it has the normal air around us. Okay, so the point of the H2 flowing in is to make sure the H2 push out the hydrogen. Why? Because if here got oxygen and then the H2 come at here at the same time, you got H2 and O2 and you heat that time on the moment when you have H2 and O2 and you heat, you will get explosion. Like not like the kaboom explosion. It's the pop sound explosion. That's why when we test the presence of H2, remember the glowing and lighted wooden splinter? Why the lighted wooden splinter will give you pop sound? It's because of the O2 and H2 together, you heat it with the fire, then you get pop sound. Falling asleep. Okay, go sleep, go sleep. Later only watch video. Okay. Can I make him vacuum? No. How to vacuum here? Don't need lah. No, like you vacuum very hard, anything cannot do. So how to take off oxygen? Technically use the H that you produce, push it, let it flow for a few minutes so the H2 will push the normal air out from here. Then inside here got no more normal air. And so the answer here should be okay, to remove all the air in glass tube. Okay, that's how we remove air, because I let the H2 flow, let him push out the air. Okay, then the next question, can the answer be to in case you mean to avoid explosion? Ultimate goal is to avoid explosion, but try not to put that because it's like bio question. If you do this, if you eat this, you die. If you do that, you die. You use phone, you die. You kena cancer, you die. So die is the ultimate result. So we, of course, is try to avoid explosion, but avoid explosion is the ultimate goal. At here is to make sure the air come out first, so to avoid explosion. So if you want to be more specific, you can write to avoid explosion at the back. But you don't just write to avoid explosion. Not very accurate. Okay. If I put oxygen instead of air, can? Or you mean to remove all oxygen in glass tube? Can. But you cannot just write to avoid explosion because they want too general already. Okay, because explosion can be caused by something else, maybe soon fire inside. Okay, can the empirical formula of magnesium oxide determined by this method? So guys, remember this, I told you there's another diagram like this. Okay, magnesium must use this method. Why? Because magnesium is so reactive that you can directly heat magnesium with oxygen to get you magnesium oxide. Okay, this is the thing that we do for magnesium, but copper cannot. Why copper cannot? Because copper he very hard to burn with oxygen. Means if I take copper, I burn with oxygen, no reaction. So we cannot use the magnesium method for copper. Then we use that's why we have this specific method just for copper oxide. Then if you reverse the process, can we use magnesium for this method? So it means I change this into MgO. Can H2 snatch the oxygen from Mg? Cannot. Why? Can Ihan snatch my girlfriend? Cannot. I'm more handsome, Cannot. Yeah. Mochi can. Hey. Okay. Then someone asked, then how the CuO form? Okay, the CuO that we form here is because normal oxidation in air. Okay, you have to been through, like you have to actually go through like years of oxidation. Only CuO can form. Means you get it from underground. Okay. Okay, can So technically, the answer is no. Okay, why? Because magnesium is more reactive than who? It's because of the hydrogen cannot snatch, so more reactive than hydrogen. Okay, more reactive than hydrogen. Then moving on, hydrogen gas is allowed to flow until the product is heating at room temperature. Means again, before we start reaction, we flow H2. Then even after the reaction, we also still flow H2. So means the flow of H2 you actually start early and end late. Okay, so this is the trend for this experiment. Again, is to do the same thing. So okay, correct. Why we don't do this? Okay, I mean, like, why do we actually need to make sure the hydrogen gas still flow even the experiment end already? Because if you actually form Cu already, okay, let's say this is the end product, right? Then you straight away turn off and you take the hydrogen gas away. The copper metal at here is still hot right now. So this hot copper will react with the air around us, and then he'll react with oxygen to form back copper oxide. So you form the chemical that you have in the beginning because it's hot copper. So you're supposed to actually let it cool down without taking away the H2. Not say not reactive, man. Correct, because but here is hot, hot then reactivity. Okay, I mean, not to say like totally change back into copper oxide lah. But got chance. The one that got chance already affect your result. Means even got one copper become back into copper oxide, your result also wrong. So you're not supposed to allow him to have chance to go back into copper oxide. Okay. Can So the answer here is to correct. I see most of the answer correct already. So to prevent air from entering because oxygen will react with hot copper to form back copper to oxide. Okay. Next one, why do heating, cooling, and weighing process need to be repeated until constant mass is obtained? Because when's the end of the experiment? Like we heat, and then when do we stop? Actually, you don't know when is the end on. So that's why you have to heat, cool, weigh, so you see the mass. Then you repeat, weigh, heat, cool, and weigh, you see the mass. So you have to keep repeating this process until you get a constant mass. Then only you know complete reaction. Until you get a constant result. Yes. So to ensure, okay, because what happened here is, you see, the mass supposed to be increasing, okay, so it's supposed to be decreasing. You see, CuO becomes Cu, so the mass supposed to decrease. So I need to know when he stopped decreasing. Then I only know that all the Cu is formed. Then all the CuO no more. Okay. Yeah. So to ensure all copper 2 oxide are completely reacted to form copper. Okay, so this will be for empirical formula. Okay, this will be for empirical formula. So if this one done, I want to do chapter 5, which is the chemical bonds. I will straight away, but guys, in the middle got alloy, got all the bronze. Okay, alloy, guys, alloy. I see the tips are also got. So, but I would say alloy very simple because it's all on memorizing, not much theory. So you just go and do exercise, you memorize the composition, memorize the percentage, then should be fine. Okay, so in the middle here, you see, the next page is, I think, next page is rate of reaction. Rate of reaction, later I got time, I do. Okay, but I try to finish off chapter 5 first. Okay, so now, then you see, page number 11 got glass and ceramic, page number 10 got alloy. Okay, all this you can do yourself. We put this question here according to tips already. So try to do. And now I see the tips have got bronze. So you can specifically focus on bronze, and then got hardness, this and that. Okay. So try to focus on alloy. And then I want to do the essay question, which is at page number 17. Hungry, get food. You see, I also eat 2 bread. If you all got any event or you want to go breakfast with your parents, okay, go lah. Okay, I'm not gonna stop you here. I'm not gonna actually like stop you from leaving. It's okay, guys. You haven't brushed your teeth yet. Actually, I also haven't. No, we demand you, ma. Wow, sure not. Oh, the good thing about online class is you might not know. Maybe I'm not wearing pants now. Just kidding. No lah, no lah. Who never wear pants at home? Hiya. Okay, why you expose yourself? No lah, just say. Assumption. Okay, it's an assumption. Okay, page number 17. Okay, this is the bonding that we all asked for. Okay, okay, yeah. Now you know why Ching Hua never on his camera in class. He cannot. His hair a bit ugly. He cannot on his camera one. No lah, Ching Hua a bit different. Ching Hua got the celebrity style. Okay. So okay, see we got compound A and we got compound B. Okay. So at here A is sharing electron. B is where you get the positive and negative charge kind of. So if I ask you guys, A is what bond? A sharing is considered covalent bond. Okay. Then B is the one that you donate and gain electron. Is ionic bond. Okay. Can So now they ask you, element R can react with element P to form compound A. Then element R can react with element Q to form compound B. Referring to diagram 7.2, which is the top one, okay? Determine the type of bonding in A and B and then explain the formation of compound, 10 marks. So guys, okay, your cat professional assassin try to sneak out on squirrel on the front yard and get stuck in the door. Hey, Sun Fai, I thought you said you want to sleep already. You're still here. Okay, so guys, in 10 marks here, how to score in 10 marks? So if you actually try to split into half, is 5 mark and 5 mark. So I will say this is 5 marks, this is 5 marks. Okay. So guys, how to get 5 mark for explanation? Can do table, can, but don't have to, because usually for this explanation, the sentence is very long. So doing table not very efficient also. Just write in paragraph form. Table usually for answers, they are very short and straightforward. But this one must write in sentence. Okay, you cannot go straight in table. Okay, so 5 point each actually very easy. You know why? So the trend is the same for both sides. You know why? Let me go with the first one first. Okay, the first time we will actually mention is you see, you say that you form covalent and ionic. The main reason you form ionic and covalent is because of what? It's because of the electron arrangement kind of. So first thing to mention is their electron arrangement. So what do we see? Okay, let's say for compound A. I will go for compound A first. Okay, I give you the trend. Later B, you try to brainstorm, and then I'll do together. Okay. So compound A, we know that electron arrangement. Okay, we can go in this way. We have two elements. We have atom P and atom R. So I go separately. So atom P has electron arrangement of 2.4 with. So writing out electron arrangement and state the valence electron, because sharing and donating electron decide by the valence electron with 4 valence electrons. This sentence, 1 mark. Okay. So if you got 4 valence electron, can you say donate and receive for compound A? No, because I know some of you all got do this before. You all like to straight away go for donate and receive. No, this one is covalent. Covalent cannot donate, cannot receive. So what's the next sentence to write? They share. No, don't go for sharing first. You have to fulfill. You have to actually understand what is the need for atom P. So P is 2.4. He got 4 valence electron. So you ask yourself, how many more for atom P to become stable? Correct, 4 more. In order to achieve SOEA, wow, you're very lazy like me. It needs 4 more or donate 4 more. No. Cannot say donate. Your answer should be it needs 4 more. Just like that. Okay, because cannot donate, cannot receive. You just say he need how many more. Then later he will share. Okay. So what's the keyword? You can say atom P need 4 more electron to achieve stable octet electron arrangement. A bit easier. See you, teacher. Gotta go church. Bye. Those who need to go church, watch video lah. Okay, then we can go for atom R. You wanna go temper? Sure, go. Take picture, let me see. Okay, so atom R, you wanna go Moss? You all come. You all wanna be funny, huh? You wanna go toilet? Why am I here? Okay, so atom R is the other one, no? Okay, so atom R got what? Atom R is the cross, so it's 2.6. Okay, I want to come physical class. Sure, come my house. Okay, atom R has electron arrangement. So same trend, you see same trend, of 2.6 with 6 valence electron. Okay. So if you've got 6, give me address. Hey, don't like that. Just say. Okay. So if you've got 6 valence electron, he need how many more to achieve stable octet electron arrangement? Correct. So use the same sentence. The atom R need 2 more electrons again to achieve stable octet electron arrangement. Okay. Now guys, like that, you get around 2 to 3 marks already. Okay. Why? Because how to get the last 2 or last one? Okay. We have to mention how many P and how many R. So actually they give you diagram is actually considered very kind. Because they don't have to give you diagram. Then they ask you to draw. That one will be more marks lah. But here they give you diagram, means you no need to actually draw it out, so the marks will be lesser. Why need to emphasize on the valence electron? Because that will be the one to decide how many more to share, how many electrons to share. Remember the way, see, imagine this, okay, let's say for here, see, Q is plus, R is 2 minus. How we need to know, need to draw like Q2R. Because when we exchange the charge, you get the number exchange, you get Q2R. So you have to draw 2Q and 1R to achieve stable octet electron arrangement, correct? Okay. But for covalent, can covalent do this method? Can covalent have plus and minus and exchange number? Cannot. So covalent bond, so cannot do this cross method. So we need to find another way to actually very similar to this. So what is the way for covalent bond to actually know how many, let's say for here, for P is 2.4, for R is 2.6, got no charge, then no charge, how to do cross method? Then how I supposed to know 1P and 2R? That's the question, kind of. That's the problem, that you're not sure how many P to draw, how many R to draw. So the concept is this way. I always tell my students, so if just now we say P needs 4 more, okay, R needs 2 more, you take the 2 more and 4 more, like charge exchange number. So you exchange the number is P2R4. Then the 2 and 4 can be simplified, become P1R2. So you're supposed to draw 1P and 2R. Okay now. So got charge quite easy because you can just exchange the charge. But if got no charge, you cannot exchange charge because there's no charge. So that's why we need the how many more to guide you. Okay, almost 8 already. Wait, don't like that. Don't remind me. Okay. Finally see the sun. Wait, I never opened my window, so I cannot see. Okay, so that's why, guys, the reason why we need to emphasize how many more is because that let you decide how many P, how many R to combine. So at here, they give you a diagram, you know got 2R and 1P. But if the other exam question, they never give you a diagram, how are you supposed to know 1P and 2R? Then you're going to use this method. Okay, how many more? Exchange number. If can simplify, you simplify. If cannot simplify, that's the answer. Okay, so means at here, we have to follow on this explanation. It's not I say how many P and how many R, 1P and 2R ma. So I have to say one atom P will combine with two atom R by sharing electron. Okay, can next time I think you can on 5:30. Hey, you all don't test me. Next time I on at 3 AM, I tell you. Okay, so can sure. You jangan jangan. No problem What is crazy people? Can also, hey, hey, sorry. Anything for chemistry. Wow. Okay. So when we say 1P and 2R combined by sharing electron, we are ready to give up our life for chemistry. I'm gonna say hey, anything for Jiahen. Hey, Yihen and Sun Fai, you all exactly say the same thing at the same time. They come for chemistry, I come for Jiahen. Wow. You all really know how to sweet talk me. Hiya. For real. Pui. Okay. So just now I say 1P and 2R, but after this one, you have to actually explain how many electrons they share. You see, P is actually sharing 4 electrons in total, but 2 electrons at both sides. You see that? Then R is actually also sharing 2 electrons at both sides. But one side got 1 R, the other side got the other R. Okay. So means at each of the sharing area, okay, they have 2 electrons from both elements. So 2 from P, 2 from R, 2 from P, 2 from R. So you have to mention that also. Okay. So how do we say? Okay, see, 1 atom P. So in total, P share how many electrons? 1, 2, 3, 4. So 1 atom P contributes. So we use the word contributes 4 electrons. One atom P contributes 4 electrons, and 2. Okay, like this. And each of 2 atom Q contributes 2 electrons for sharing. So means 1P use 4 electrons for sharing. Then each of the 2 Q at the back at the side, each of the Q give 2 electrons sharing, 2 electrons for sharing. So this sentence means that 1 atom P contribute 4 electrons, and each of the 2 atom Q contribute 2 electrons for sharing. Okay, so I have to mention like each atom contribute how many for sharing. Okay, so technically, you can just conclude a covalent compound PR2 is formed. Okay, guys. If I write in point form, no problem, right? Can. But okay, point form very dependent on school teacher. If your school teacher accept point form, then okay. If your school teacher don't accept point form, must in essay, then you have to follow school teacher. SPM can point form. SPM can point form. But now your exam is not SPM. The teacher mark the paper. So follow the teacher. Okay. Always write essay as default because sejarah. Point form in full sentences, my teacher say. Also means you write point form but full sentence. Then okay. Then okay lah. If your teacher like that, okay. It's fine. Okay. So guys, compound A, settle. Then how about compound B? So compound B is ionic bond, slightly different, but the trend is almost the same. So you see, guys, after you done, guys, you all still got space. I hope you all still got space. Not so big. Okay, so compound B. Okay, so the first 2 sentences are same. Say the arrangement, say the valence electron, then he donate and gain how many electron? Okay. Well, guys, at 8 a.m., I still got 130 students. Not bad. 130 crazy people. Okay, so moving on here. So what we say? Atom what? We got atom R and Q. Okay, we can say for Q first, R first. Teacher, I go first, need to eat breakfast. Okay, bye-bye. Bye-bye. Okay, so atom Q has, I thought you will copy paste. I wanted to, but I cannot. I need to show my appreciation. If I copy paste, I will sleep. You OT until 9 a.m. also no problem. Oh, you sure? Don't fall asleep. Okay, so atom Q has electron arrangement. So okay, Q is what? Q is on the side one. So okay, guys, I test you all a bit. Extend time more. I confirm extend one, guys. I cannot finish. I confirm extend already. I go your class from sleepy until cannot sleep. Okay, guys, I ask you, Q at here is 2.8 ma. What is his original arrangement? 2.7? No. Why? Yeah, he is positive charge ma. How to form positive charge? Positive charge supposed to be donate electron. So means before he donate, he's supposed to be correct. 2.9 Hiya, why got 2.91? 2.8.1, correct. So Q supposed to be 2.8.18 electron arrangement of 2.8.1 with 1 valence electron. Okay. Can 2.8.1 Then how about R? R is supposed to be, R is 2 minus ma. So means if you check, or you go to toilet, bye. Yeah, if you check a dot, it's actually already very obvious, it's 2.6. Okay. Then do you see got 2x? Why got 2x? Because one x come from this Q, the other x come from the other Q. Okay. So from here, okay, of course we can further on Q first, okay? So we can say each atom Q, because they got 1 valence electron, guys. 1 valence electron is donate or gain. Which one? 1 valence electron. Donate, each atom Q donate 1 electron to form ion. Now after you change the electron, you should form ion Q plus to achieve, again achieve stable octet electron arrangement. Okay, save me some time lah. Then same concept, talk about atom R. So atom R has, why got 2 has? Sounds so wrong. Okay, has electron arrangement of 2.6. Okay, with 6 valence electron. Okay, guys. So now what's the next sentence? You have to say he gain or donate. So 6 ma. So supposed to gain. Gain how many? Must write very carefully. Gain how many? Gain 2. Okay. So the answer here is supposed to be, okay, atom R gain 2 electrons to form ion R2 minus, 2, because you gain 2 ma, so 2 minus, okay, to again achieve stable octet electron arrangement. Okay, so you have the 2 things ready, ma. One is Q plus, one is R2 minus. Combine them, you form your ionic compound. So we can say 2 ion Q plus combines with 1 ion R2 minus to form ionic compound Q2R that is strongly attracted. Okay, that's extra lah, just in case, because if your exam have more than 5 marks, you can just add this in. Strongly attracted by strong electrostatic force. Okay, electrostatic force appears to be in anything that has charge. For example, ionic bond. For example, metallic bond. Metallic bond also got electrostatic. Cannot write opposite charge will attract one another? Can? What is lion? Wait, sorry, that one is one ion. 2 ion Q plus with 1 ion R2 minus. I didn't realize I write until lion. My 1 too near already. Sorry. Sorry. Okay, guys. Really copy gone. Hey, no. Teacher, what is electrostatic? Electrostatic is the attraction force between positive charge and negative charge. So anything with positive and negative got electrostatic force. Okay. Teacher, just now the copper 2 oxide heated strongly, color will change from black to brown. The brown color is what? The copper metal. Copper metal. Copper metal is brown. Can say metallic and van der Waals force for what? For compound B? Cannot. This is not even metallic, not even, and van der Waals only in molecule, only in covalent compound. Metallic only in metal. Half equation no need to mention, no need because this is only 5 marks. For each topic, for each writing is only 5 marks. But if they have more than 5 marks, then you have to put in equation. Okay, need to go already. I got other class. Wow, you're 8 AM got other class. See. Just in case if you guys are curious about what's the equation, so you can write this. So Q become Q plus because he donate 1 electron. Okay, then if you want to talk about R, he gain 2 electron, become R2 minus. Like that. More than 5 marks can write equation. Okay, how is van der Waals force formed actually? Van der Waals is between one molecule with another molecule. Means if I have like, okay, let's say if I tell you hydrogen gas, okay, hydrogen gas is sharing of electron like this, is H2. Okay, so between the sharing is covalent bond. But what is van der Waals? Van der Waals is with another hydrogen gas. So means this is one H2 gas. This is another H2 gas. Between 2 gases, they have a weak van der Waals force. So van der Waals only between one molecule with another molecule. Okay. How to know how many atoms for each element in ionic compound? You mean this one, like the how to know how many things to draw? By crossing the charge. So Q plus and R2 minus, right? You exchange the number of charge. So the 2 give to the Q, the plus no number, right? So the R also no number. So if you exchange the number already, you get Q to R. So if you draw 2Q and 1 R. Okay, all good. For the explanation of covalent compound, no need to say how many bonds. Can, if you want to put inside also can, but because of the 5 marks. So again, guys, I also give you extra marks from here because some of you asked about it. So you can say, what bond is this? This is actually 2 pair of sharing. So if it's 2 pair of sharing, this is called double bond. And you have double bond at both sides. So we have to say, you can say like 2 double covalent bond is formed. As I mentioned, this is actually extra. If you go more than 5 marks, you can try to put all this in. Okay, all good on the essay writing. This one I see the tips high chance. But if never come out, let's pray. Tomorrow must come out. So you wrote atom Q instead of atom R in compound A? Compound A, I got right atom Q. Oh, sorry. Sorry. This one is atom R. Write too fast, write too fast. Now, like what also know, then exam that time, what also don't know. Not like that. You do more question, then you know. The tips you're talking about is the model Pintas one, right? I don't know. My student just sent me for, they say from school teacher also got, from their Telegram group also got, from their friends also got. So I try to take the one from school teacher. School teacher. Okay, but it's almost the same. I would say it's almost the same. Okay, school teacher one same as the one in other group. Okay, so for 18 guys, 18 this one almost the same thing already. So I don't do already because I know you all very tired already. Okay, 2 hours already. So I try to go for a next chapter because actually this chapter mainly they ask about this Okay, if you can write this in this chapter, I guess it's fine. Okay, the rest of the bonds like hydrogen bond, like dative bond, got metallic bond, they want minor question. Okay, I don't think they can come out maybe in paper 1 got lah. I see paper 2 don't have dative bond, don't have metallic bond. Would they ask for drawing? Possible. So you might need to know how to draw. Maybe you can practice on question 9C. This one. I need to draw. Okay, the answer provided so you can do it yourself later. So drawing, I would say drawing for ionic is easy because ionic is you just throw electron to the other side. But sharing is one that you have to brainstorm on how many electrons to put inside. You think drawing is easier? Okay, if you think drawing is good, it's easier, then hopefully they ask for drawing lah. But maybe other people think drawing harder. Okay. Chapter 5 usually come out for what usually come out for SPM? This one? This is what usually SPM like to ask. And this chapter is mainly on ionic bond and covalent bond. The other bonds are small bonds are not very important. Main question is ionic and covalent. So as I say, if you can explain A and B like this, you can score very well already. Chapter 5 structure will ask what? Ask drawing, ask you list out electron arrangement. Okay, ask you what bond, ask you what force. Like that. Possible one. They ask you like, oh, what is the electron arrangement for atom Q? Like that. 1 mark. And then they ask you what is the bond between an element Q and element R. Like that. Okay. Covalent is Van der Waals force. Yeah. Covalent appear between molecule and molecule. Covalent molecule and covalent molecule. Okay. Can So guys, after this chapter already, I would like to go for one of the, I see one question in the tips is talking about the pH and electrical conductivity. Okay, which is on the chapter 6, Form 4, chapter 6. So right now, I would like to discuss one of the question. You all go for page number, let's see, page number 20. Okay, page number 20. Yeah. You hear your parents waking up. Wow, see your parents see you at 8 a.m. you are studying. Whoa, they'll feel like my son, my daughter finally. Okay, page 20. Okay, so finally mature. Chill. Okay, ma, you see, you prove to your parents. Okay, you got study one, not everyday play phone. Okay, so talking about electrical conductivity, this chapter also got ionic bond, covalent bond, also got electrical conductivity. So let's let you all see a bit first. So at here, you see is for this part here got this. They ask you to test the electrical conductivity and the melting point between ionic and covalent compound. Okay, so if you see lead-2 bromide and naphthalene. So guys, I'll ask you first. Lead-2 bromide is ionic or covalent? Which one? Lead-2 bromide. Ionic, because it's metal and non-metal, so it's ionic. Then naphthalene, this one obviously is covalent. The name very complicated one. Okay. So you see ionic compound at solid state, the bulk does not light up, means that it does not conduct electricity. But in molten state, the bulk lights up. Naphthalene at what condition? Also the bulk does not light up. So what can you conclude from here? Means ionic compound conducts electricity only in molten state, but not in solid state. Then naphthalene never conduct electricity. Why? Because covalent where got charge. Also in aqueous, isn't it? Yeah, of course, aqueous means molten plus water. So if got molten, got ions, means confirm can conduct electricity. Yeah. So the full definition for electrical conductivity will be ionic compound able to conduct electricity in molten or aqueous state. But here got no aqueous. So we can just mention the molten. Okay. So now they say state the difference in terms of electrical conductivity and melting point, 10 marks. Okay, guys, this one 10 marks a bit hard to get because I know you all can answer, but I don't think you all can get full 10 marks. Okay, so like let's say for here, okay, in terms of electrical conductivity, okay, electrical conductivity. So we say what we say just now is we try to explain the observation first. Okay, we can write out first. So we can say lead 2 bromide conduct electricity in molten or aqueous state. Why lead 2 bromide can conduct electricity in molten or aqueous state? Because of what? It's a what compound? It's an ionic compound. So ionic compound got what? Got free moving electron? No. Ionic compound is free moving ion. Okay. When do we say free moving electron? The one in metallic bond. Metallic bond only free moving electron. Okay, two different things. Okay, so we can say molten lead 2 bromide. Okay. Yes, Pavitra, your answer also correct. Okay, lead 2 bromide consists of free moving ions to carry electrical charges. Okay. Known to say why the lead 2 bromide does not conduct in solid. Need. I finish this one first. Then only we go for why cannot in solid. Step by step. Okay. So next one, lead 2 bromide. Lead 2 bromide, solid. He also got ion. But then, 咨询 which page? Page 20. 20, 第20面. Okay, lead 2 bromide solid consists of ions, but not free moving. So what do we say? Consists of ions in fixed position. So the got ion, but the ion cannot move. Fixed position in crystal lattice structure. So what is crystal lattice structure? Means they are arranged according to opposite charge. Means plus, minus, plus, minus, plus, minus, plus, minus. So crystal lattice is the meaning of that opposite charge. Okay, so when they are arranged in fixed position in crystal lattice structure, so they cannot move. Even if they can carry charge, they cannot move. So we can say there is no free moving ions to carry electrical charges. Okay, that's for lead 2 bromide. Still got who? Still got naphthalene. That's how you see how to get 10 marks. It is all in the details. Like see the crystal lattice structure 1 mark. If you never write that, you lose 1 mark. Okay, so next one is naphthalene. So we can say naphthalene does not conduct electricity in any state. Why? Because we know naphthalene can say tied by strong electrostatic force for solid state of electrobromide. So means you say like consists of ions that are tied by strong electrostatic force for solid. No, because strong electrostatic don't make them in fixed position. You see, like even in molten or aqueous state, they still got strong electrostatic. So in solid state, the main reason is they are in fixed position in the crystal lattice structure. Strong electrostatic cannot explain in solid. Moving ions in electrostatic has been overcome. Oh no. Moving ions still got electrostatic force. They still have electrostatic force in free moving ions. Because still got positive and negative charge. As long got positive and negative, then got electrostatic. Okay, so from here, naphthalene consists of what? Okay, so the opposite of ion is neutral molecule and no free moving ions. So nothing to carry charge. This exercise from where? Forget a long time ago. Some of them from school past year, some of them from SPM past year, some of them from model papers also got. All the questions we get from like all type of question banks. So we try to choose whichever is more common in exam, then we put inside here. Okay, so guys, I've finally done the electrical conductivity. Here you get around 6 marks already. Okay, so next one is melting point. Okay, so who's supposed to have higher melting point? They never say, but what do we know about melting point? Ionic and covalent, who's supposed to have higher melting point? Ionic, because Ionic got what? Strong electrostatic force. But covalent, okay? Covalent, you don't say covalent bond is weak. Covalent bond is strong, but to actually melt or bond a covalent compound, you don't have to break the covalent bond. You just have to break the weak van der Waals force. Correct. Okay, so you can say melting point of lead-2 bromide is higher because it contains strong electrostatic forces between ions. Okay, so if got strong electrostatic force, we know that a lot of heat energy is required to overcome the strong electrostatic force. Okay, then the other one for covalent, so you can say melting point. Wow, I still no space today. Shit. I hope you all got space. Melting point of naphthalene is lower because there is weak van der Waals force between. Okay, so electrostatic force is between ion. So van der Waals force is between molecule. So you know that a little heat energy is required to overcome the weak van der Waals force. Okay, guys, after the electrical conductivity, because this one I see tips got lah. So actually this one not very common, just that I see this time is in essay ma. They specifically mention electrical conductivity in essay. So I purposely do this because tips got show. These tips naphthalene or naphthalene? I write wrong man. Naphthalene. With the H. Zin, your one is with the H, the right side one. Second one. So I write wrong. Which one I write wrong? I don't see my mistake. I'm blind already. Oh no. This one. Why my screen? Oh, okay. So I think this one is wrong. Oh, I see. Naphthalene. Hungry already? No. Puasa today. No finish, no eat. Okay. One more question. Of course, I'm going to do one more question. One last one. Rate of reaction, chapter 7. Just a reminder, I scared this one come out, so I remind you a bit. Okay. Where was the question I see yesterday? Okay. Just a reminder, this one you all remind yourself, okay? Page number 14 got calculation for pH and pOH. So the calculation I scared will come out. So you all try to do that. But because that one calculation very simple, so just remind yourself. So how to know lead-2 bromide is strong electrostatic? As long as ionic compound, then it's strong electrostatic. Because ionic compound got positive charge and negative charge. So between positive and negative, then it's strong electrostatic. Then covalent no charge. And then don't have electrostatic. Covalent compound is van der Waals. Two different things. Okay? Can Okay, so if okay, I do one more question. If can, I do two more. See. Okay, especially because this one is the last question, question 11. Is compulsory. The essay that is compulsory. So you cannot avoid. Okay, there's one compulsory essay at the last question. According to tips, is rate of reaction. I see a lot of tips all say rate of reaction. So let's do one rate of reaction question. Okay, so let's say if I go for page number 25. Page number 25. You all done? You all done with this? All done? Okay, page number 25. I do this because I scared need to sketch graph. So I do this one because this question got graph. Page number 25, okay? Okay, guys, wait, let me wake up my girlfriend first. She need to go and do her nails. I need to wake her up. Wait. Let me go wake her up first. One moment. Okay. So long no see, still need to eat狗粮. Okay. So guys, I'm back. Okay, we got two experiments here. We got experiment 1 and experiment 2. Both of them are actually using 3 grams of marble, but one is granule, one is powder. So you see from here, you know actually this is a very obvious factor here. So guys, just to remind you guys a bit, what are the factors that we actually have in our syllabus? So we know that we have few different ways to speed up your rate of reaction. At here is granule and powder. So we know this is size. So size really matter. Sorry. Sorry, guys. Okay. Oh, no. Sorry. What you hear? Nothing. Size matter, ma, you see? Small size better. Because small size, larger surface area, ma. What you're thinking? Hiya. Okay. So go. Okay. Sorry, guys. Sorry. I'm very sleepy. Let me make some joke. Okay. Okay. So what are the factors there? Okay. Number one, we got size. Okay, but size is not the ultimate answer because size relate to what? Size relate to surface area. Okay, surface area exposed in full lah. Okay. Number two, we got concentration. Okay, concentration also not the final answer. Concentration usually it relates to number of particles per unit volume. Okay, what is granule? Granule means big size, like a piece, one piece, big size. Then powder means powder lah. Okay, so in exam, if question asks factor, we need to write size or total surface area. If they ask you factor, size. But further explanation, they ask you explain. Then you have to mention surface area. Okay, granule equals to chip. Yes, granule and chip, same. Granules equals to chip equals to pieces. Okay, after factor 2, we got factor 3. Factor 3 is temperature. So what's the explanation for temperature? You know that is your kinetic energy increase. Okay, you have activation energy, this and that. Okay, later we're gonna explain that in terms of collision theory. Number 4 got what? Number 4 got catalyst. So what's the explanation for catalyst? Catalyst is providing alternative pathway with lower activation energy. So lower activation energy. So these are the keywords. Got one more factor is called pressure, but pressure not important. So that one ignore first. Okay. So let's try from here. Since this is size. So from here for experiment 1 and 2. So you see powder and granule, we say just now size I want smaller or bigger. If I want to increase rate of reaction, usually I want smaller in size because your surface area will increase. So smaller size give you bigger surface area. And if you have bigger surface area, you have more collision of particles, this and that. And then eventually you have a faster reaction. But from the result, how you know experiment 2 is supposed to be faster? What's the point that you see that, oh, I know experiment is faster, experiment 2 is faster? Is you see the volume of gas at the maximum volume. So experiment 2 actually achieved 35 cm3 at the earlier time. You see, he hit 35 at 120 seconds. But experiment 1 hit 35 at only 140 seconds. So means experiment 2 actually finished first. You see, whenever you get constant volume, it means that the reaction finished already. So you see reaction 2 finish first. The reaction 1 finish later. So you know reaction 2 is faster. Okay? But then they say name the gas release. Something suddenly asked about gas. Because guys, in real reaction, it's all the reaction you learned before in chapter 6, chapter 5. Then they take it to measure rate of reaction. So it means you're supposed to also know the chemical equation, what's happening inside, what's the product, this and that, what's the observation. Okay. So what is the gas that produced from the both experiment? Okay. So you have to understand what is adding together. You are actually adding hydrochloric acid with marble. What is marble? Some of you give me H2. Wrong. Hey, my cat screaming. Sorry, I too loud already. Sorry. Okay, so guys, if you do not know what is marble, please write this down. Marble is calcium carbonate, CaCO3. For those who give me H2, no. You know why wrong? Because H2 is acid plus metal. Now it's acid plus metal carbonate. If you add acid plus metal carbonate, what you form? You scam what? Because I never tell you marble is CaCO3. Now you let me scam already, ma. Don't get scammed in exam, I tell you. Okay, so what's the equation that you're supposed to see? So I got hydrochloric acid plus calcium carbonate, CaCO3. What do you form? Water and CO2 is formed, is it? Correct. Yes. So guys, we can do the normal way. If you see like HCl is actually positive ion, negative ion, positive ion, negative ion, right? So what you're gonna do is exchange girlfriend, exchange partner. So your Ca and your Cl becomes CaCl2. Okay, and what is left? You're left with CO3 and H, right? But the CO3 don't like the H. The CO3 first will release CO2, then the remaining O, the last O, because CO3 take out CO2, got one more O. The one more O will combine with the H to form the H2O. So whenever you add acid plus any metal carbonate, not just marble, any metal carbonate, you will form salt and water and carbon dioxide gas. So what do we know? Whenever you see CO3, you always form CO2. This is fixed. You see CO3, must form CO2. You see CO3, must form CO2. Okay, so means what is the gas that we are collecting here? Carbon dioxide gas. So our answer here is supposed to be carbon dioxide gas. Okay. Then what is the test to test carbon dioxide gas? Remember, to test CO2, just now to test O2, we use glowing wooden splinter. To test hydrogen gas, we use burning wooden splinter. Yes, to test carbon dioxide gas, lime mortar turns. You see Yihen? Yihen say lime mortar turns spermy. So bad. I don't know who teach one this guy. Lime mortar turns spermy. All this. Disappointed. Okay, no lah. Okay. So they say describe. I know, guys, you all give me answer all correct. Okay. But the thing is, don't write for me. Okay, just kidding, just kidding. Okay. I'm gonna take out the recording. Wait, it's okay. To burn school use nuclear. Wait. So the thing is, okay. Using lime water turns milky, turns cloudy, turns chalky. Also okay. Okay. But then you have to describe. So describe means you have to kind of write like a procedure in one sentence, then your result. Okay, so what do we say? We have to say that we actually have to bubble. Bubble means that you push the gas, or maybe you collect the gas edema, then you push the gas into the lime water. So bubble the gas, release into lime water. Okay, then we know lime water turns cloudy. Cloudy also can, milky also can. Teacher, what is Ke? What is Ae? Ke is kinetic energy, Ae is activation energy. Can I flow the gas? Can flow the gas release into lime water? Also okay. Lime water is one word or two word? One word. Lime water is one word. What's activation energy? Wow, you ask me what is activation energy? Tomorrow exam GG if come out activation energy. Can you write channel the gas? Can channel also okay. Activation energy is like this, guys. Remember when you learn catalyst? Catalyst, you have a graph like this one. Your energy level like this, and then go up, and then come down like this. Activation energy is the maximum at the top, the highest point of the graph, which is the energy needed to activate the process. Because every reaction, they first must absorb energy first. Only they can achieve activation energy. Only can actually form a new product. Just like you have a crush, okay? You have a boy that you like. Okay, you need to everyday talk to him, okay? Buy him food, okay? Go out with him, okay? Until enough energy only can get into boyfriend relationship, so activation energy is the energy needed for you to start a reaction. Okay. Will it ask for definition? Not really. Activation energy, they don't really ask for a definition. Okay, but they like to ask in catalysts, like how catalysts increase your rate of reaction. Then that one you know is to give you the lower activation energy, the alternative pathway, okay, this and that. Okay, so moving on. Referring to the two table, can you do the calculation for average rate of reaction? How to calculate rate of reaction, guys? What is the formula for rate of reaction? Just now we learned the number of formula, but rate of reaction also got formula. Rate of reaction, usually the usual formula. That's why the way I say usual is because it's not fixed. Correct? Okay, MV1000? No. Rate of reaction cannot use MV1000. Okay, rate of reaction formula is actually, is right now, is usually volume over time. Okay, but it's not always volume over time. If your exam question is about increasing mass or decreasing mass, you can use mass over time. Then your unit will be different. So at here, because we use volume over time, it's because you're collecting gas. You're collecting volume of gas. So you take the volume of gas over time. Must be over time because rate of reaction. How do you know some reaction is fast or slow? Time is your factor. So you always have to divide time. So it's either volume over time or mass over time. But here is volume lah, because it's volume of gas collected lah. So how to calculate it? So we know for experiment 1, we got experiment 2. Okay. So how to calculate rate of reaction? You take volume over time. So volume that you collected for both experiment is maximum 35. Okay, but the time is different. So experiment 1 is 35 over 140, but experiment 2 is 35 over 120. So from here, what we have, you all press the calculator lah. 35 over 140, 35 over 120. I think this one I can do 0.25. Okay, cm cube per second. Okay, it's volume over time, but so it's cm cube over second. So 0.25 cm cube per second. But the next one, I don't know. Guys, 35 over 120 is what? Got calculator or not? If not, I have used my desktop calculator. 0.29, thanks. 0.29 cm cube per second. Don't forget unit, because you're taking cm cube, taking volume in cm cube over time in second. So cm cube per second. Then you compare the rate of reaction. So how to compare rate of reaction? Look at the number lah. 0.25 and 0.29. Which one is higher? Experiment 2 lor. So, and one thing, guys, rate of reaction cannot say fast or slow. Okay, rate of reaction only can use what? High or low. So it's either higher or lower. Cannot use faster or slower because rate must be high or low. Greater can, but cannot fast or slow. Okay, greater can, that one acceptable. But I would say high can lah. Bigger cannot lah. This one not size ma. Okay, so from here we say rate of reaction for experiment 2 is higher than experiment 1. Okay, explain your answer in B2 referring the collision theory. Here comes the common question in rate of reaction. Collision theory must know how to do. So hopefully you all still have a bit of idea about it. Collision theory is always trying to relate from the factor to the explanation, and from the explanation relate to the collision, frequency of collision, frequency of effective collision, then only relate to rate of reaction. Okay, so let's say this is size. So what do we know about the explanation for size? Just like I mentioned. So when size is smaller, you got bigger what? Bigger total surface area. Okay. So if you got bigger total surface area, means your particles got more area to collide. So you say frequency of collision increase, frequency of effective collision increase, then rate of reaction increase. So it's a trend. Collision theory actually is very simple one, but you need to know the trend. Okay. So we know lah. Okay, so from here, size of actually it's marble, so we write in the full name, size of calcium carbonate used in experiment 2 is smaller than experiment 1. So when size is small, it's good. So from here, so total data 要完了. You using data? I'm so sorry. Use data also want to come for my class. 3-hour class confirm data finish bro. Data just for 嘉恒. Only 8th of January. Shit. Okay, so total surface area of calcium carbonate exposed to what? Now you're adding what to what? You're adding calcium carbonate into hydrochloric acid. So you have to say exposed to hydrochloric acid is larger. Or you can say bigger, also can. So you have larger total surface area exposed to acid. So when you have more exposure, particles can collide more often, more frequent. So that's why from here onwards, you can say frequency of collision. Okay, again, guys, just like just now, I mentioned just now, like distance between who and who. Here also collision between who and who, not me and you, okay. Teacher, how to get video? Okay, sir, so how to know the size big or small? One is granule, one is powder. Granule bigger, powder smaller. Granule is piece, cheap. Powder then very, very small. Okay, for how to get video recorded, guys, promote myself a bit. Go and find my YouTube channel. My name, Jiahen Chemistry. Okay, search on YouTube, Jiahen Chemistry with the chemistry behind. Actually, no lah, guys. I don't really post video. I just post some basic videos for revision. You never know I got YouTube. Siwen, you never know I got YouTube. Hi. No, the YouTube I usually just post as a, like this class I usually post as a backup. Okay, so not really a YouTuber. Okay, I just do for fun. Okay, you never say not like Liang Jie or Liang Jie every time say. No lah, I don't really promote my YouTube channel. I just post very little videos because Liang Jie very frequent post video. I just post when it's near to exam. Normally I'm very lazy. Okay. So frequency collision between who and who? Between the first thing is the powder, between calcium carbonate and what? Okay, between who and who? Liang Jie promote until got people complain. Is it? Tsinghua merchandise also come. I don't really care. Koko don't care one, okay? I care about waking up at 6 to teach you all. Okay, yes, correct, guys, because you see, collision must be between the two chemicals that you are actually reacting. But here you must be more specific. The calcium carbonate actually colliding with who? So if you try to write out the ionic equation, so guys, you see, this is chemical equation. I teach you all a bit because I scared this one will come out. This is called ionic equation. Can you convert ion? Sorry, this is called chemical equation. I say wrong already. You see, I'm very sleepy already. This is called chemical equation. Can you convert this to ionic equation? So how to convert chemical to ionic equation? For the calcium carbonate question, usually you need to be like this. Yeah. Okay. A usual way to convert chemical to ionic is by cancelling off ions that is the same. Okay, so from here you see, what's the meaning of it? Inside HCl got H plus, got Cl minus, CaCO3 got Ca2 plus, got CO3 2 minus. Okay, these are all the ions inside the two chemicals here. But after reaction, CaCl2 is still Ca2 plus, still Cl minus because of the salt. Salt is always having charge. But this two is not salt. Carbon dioxide is gas. Water is molecule. This two is no ion. So what is the changes at here is, you see, H plus change become H2O. Then you see CO3 becomes CO2. But then you realize Ca2 plus is still Ca2 plus. Cl minus is still Cl minus. The symbol and the charge is exactly the same before and after reaction. So your job is to find out this guy and cancel him away. The rest is your answer for ionic equation. Means what? Means from here, I cancel this. My answer will be left with H plus CO3 2 minus. You form CO2 and H2O. Okay, like that. So it's actually the carbonate salt, okay, colliding with who? The H plus. So means your answer here supposed to be calcium carbonate and hydrogen ion is higher in set 2. Okay, if it's insoluble salt, insoluble salt is just focus on the insoluble salt. Then that will be your ionic equation. For example, let's say if I tell you, okay, if it's an insoluble salt example, insoluble salt. Imagine if I got, let's say, maybe PbNO3 2 plus K2SO4, you get PbSO4 plus KNO3. So this is actually an insoluble salt. So how to convert this into ionic? You just look at this. Just look at the insoluble salt. And what ions form this insoluble salt? Pb2 plus SO4 2 minus. You form PbSO4. That's all. Insoluble salt, ionic equation got shortcut one. Means you don't have to like find out all the ions, this and that. Okay, you just focus on the insoluble salt and the ions that form the insoluble salt. Write this out, then finish. Okay. So moving on here, guys. After frequency of collision, final answer will be frequency of effective collision. Because normal collision is not enough. Okay. You need to collide until effective collision. Again, guys, the full sentence is between calcium carbonate and hydrogen ion is higher in set 2. Okay, all good? Can okay. Okay, next one. Sketch the graph of volume of gas against time. So guys, I told you before, before you sketch your graph, check 2 information. So we can write out here sketch graph. Sketch graph. First information is to check what? Is to check the rate of reaction, because rate of reaction decides your what? Decides your gradient. Number 2, check the number of mole, because number of mole decides your what? Decides your height of the graph. Okay. So why I need to do this? Because you see, we know that rate of reaction of 2, okay, is higher than 1. Eugene leaving. Okay, bye, Eugene, bye-bye. Yeah. So experiment 2 is higher than experiment 1. So means the gradient of experiment 2 supposed to be steeper than experiment 1. So means we can know from something like this. Yeah. So means at here, experiment 2 is steeper than experiment 1. The gradient. Okay. Okay, but then the height, number of mole for the height, do they have the same height or different height? If it's different, then you have to check who is higher, who is lower. But how you know, how you all know it's same? Because how to find number of mole? If you check the question, do you see they use same volume, same concentration? Do you know how to find number of mole if got volume and concentration, which is known as molarity? Which is 1.0 mole is actually your molarity. This one is volume, right? So if you got MV, you can use MVO 1000. Correct. So, but then you see, if I do MVO 1000, do you see the number is exactly the same? So if number exactly the same, and for MVO 1000, then means that your number of mole is the same, right? So means at here your experiment 2 is equal to experiment 1. So means what's in my conclusion? Means your graph supposed to be different gradient but same height. So your answer is supposed to be something like this. So let me draw the axis first again. So y-axis supposed to be volume of gas in cm cube. Okay, then what x-axis is supposed to be time in second. So your graph, the first thing we know, gradient different, same height. So I will draw one curve first. That is okay, like this. So it's supposed to be curve and then eventually constant volume. Okay, then you're supposed to have another line that is actually steeper gradient. Steeper gradient, then like that. Okay, you should touch the same height lah. So technically it is different gradient, but same height. This one draw on graph paper? No, this is sketch. Sketch, just draw on the exam paper. They'll, if it's graph paper, will be plot the graph and then they'll give you the table. Okay, but then it's sketch, no need to draw on graph paper. But of course, you have to label lah. This is experiment 2, this is experiment 1, because 2 steeper than 1. Okay, but they have the same height. And then if can, you label the volume is 35. Both of them stop at 35 volume, 35 cm cube. So if either the volume of molarity is different, then there will be difference in height. Yes, means if your M and V, one of it is different, then your MV over 1000 will be different, right? Your number of one will be different, then you have different height. Okay. So when volume is the same, both line will join up at the same end. Volume and molarity same, then be the same height. Need to write the time? No need, no need. No need. No need to write the time. The volume can write. Volume don't write also okay actually. Because the 2 mark come from where? The 2 marks for this question is sketch correct. Okay, sketch correct, and then labeling correct. 2 marks. Oh, my back pain. Okay, nice. Almost 9 o'clock. Oh shit, 3 hours with you guys. Okay, guys. Let's go OT 1 more hour. Don't hey, I'm very hungry. Okay, so guys, if okay, the rest still got the next page also rate of reaction. Okay, you say puasa ma. Teacher, question 11, you not usually writing experiment? Not anymore. Question 11, not supposed to write procedure anymore. Write procedure is old format. New format question 11, even if they ask you to write procedure, it will be very little mark. Not to say like write procedure 10 marks, no. The new format for question 11 is HOTS question. Means it can be 5 marks, it can be 8 marks, it can be 6 marks, but then no need to write procedure. No need to describe experiment in long way. Okay, so question 11 nowadays, they like to ask you to apply your chemistry knowledge to solve daily life problem. HOTS question. Okay, that's the question 11 style right for now. Okay, but I think school teachers sometimes when they do their own paper, they still put procedure writing. But now it's government paper. Government paper, I guess I can guarantee you no procedure writing. Okay, so no experiment. Because no confirm no, because government paper don't have already. So where do they ask us about procedure writing? They will never ask you procedure writing in paper 2 anymore. That is what they announced lah. So if got then they scam us. Then no preparation of salt. Got. Preparation of salt is not considered like not exactly the full question for describing experiment. You still need to know a bit like what plus what plus what, because they can still ask you simple stuff like what salt is needed to form this salt. Like acid plus what to form salt A, acid plus what to form salt B. So preparation of salt is a topic that can ask you, not just procedure. Procedure, if they ask a bit not a lot. So no need to actually memorize procedure. Supposedly no need one. That's the trend they are trying to teach. Government new format is trying to teach that no need to memorize procedure. But somehow you need to know a bit so no need to really focus on procedure writing. Okay. Teacher, do drawing setup apparatus got in exam? No need, usually don't have. Will they ask us to write the whole preparation? Got chance, but not really in this coming exam. Not, and then if usually come up, I think maximum 5 marks. But I see preparation for salt. I think one of the tips got. So is to be safe, you go and study a bit. But like the salt one, 5 mark one have chance to come up. Got. Salt definitely got chance to come up. But as I said, today 3 hours, I cannot cover until salt. I almost cover, I cover chapter 2, 3, 4, 5, 7, So I cover 6 chapters out of 8 chapters already. So chapter 8, alloy easy. Okay, alloy that one memorize. Chapter 6 is salt. That one, if I need to cover that, another 3 hours. So you all try your best on doing this exercise first. Okay. I see got one tips got say the test for anion, the test for cations. So salt preparation, test for cation, test for anions. That one really need to take a long time. So that one need to for your own. Then if chapter 6 is essay beside preparation, need to focus on what? Test for ions. If salt come out in essay, it's either salt preparation or test for ions. How to test positive ion, how to test negative ion. Remember the ZAPCM table, the qualitative analysis. Yeah, that's essay in salt. I mean salt in essay. Okay, guys, can so guys, before I end the class, okay, ZAPCM that one in DNA. Wow, sure not. Okay, guys, before I end the class, let me take a picture. I want to show everyone. After 3 hours, still got 97 of you. Chapter 7 for compulsory essay mostly is theory. Yeah, collision theory, I can guarantee you confirm got. Okay. Teacher, can you show the Ionic equation again for this one? Then besides that, cost 20 mark. Of course, they will ask the rest like calculation. Like ask you what factor, ask you what are the possible factor, ask you equation, ask you product form, like the gas release, ask you what is a test to test the gas. So they will here and there they will combine together to get 20 marks. Teacher, anion test need to memorize how to carry out chemical tests. Yes, if you want to go for test for anions and test for cations, that one must memorize all. Only you can master the topic. That's why very hard. Chapter 6 is the hardest chapter in the whole Form 4. Okay, so you pray hard. The question don't be too hard lah. That's why I don't plan to do that here because really cannot. Unless we add another 2 hours, 2-3 hours. Don't be so cruel. No, I'm telling you the truth. Okay, anion test and cation test must memorize, and it's hard to master the topic. But if you master it, you will realize it's actually quite fun. Can 2 more hours? Don't Coco already, you know. Coco this year 28 years old. I need to take care of my health. Daily application for chapter 7 important in question 11. Yes, because question 11 is daily application. So the previous trial exam for Form 5, right? It came out for them is they give chicken. One picture is chicken drumstick. Okay. Then the other picture is whole chicken. Then they ask which one cook faster. See. Okay. Yeah, man, looks like 18. Year 18, where go? Oh, wow, you all make me sugar rush. Hiya, 28 already. What 18? Okay, so application explanation is same as collision theory. Yes, so they will ask you if they say explain in terms of collision theory, and then you should go in collision theory. But if they never say in terms of collision theory, just the common explanation. Like you say, because chicken drumstick is smaller size, then got largest total surface area. So when you got more area exposed to the heat, he cook faster. No need to link to collision theory. So usually collision theory, they will mention using collision theory. Like that, they have a trend like this. Okay. But guys, finish this PDF, please. Okay. I know you all never finish my blubber book. Okay. I know you all never do all the blubber book. Okay. But please finish this PDF. Got do got finish, you know? Do how many questions? 1. Do finish already. Blubber book also don't know throw where already. Wow, this guy. Now 80 pages done. Wow, good progress, good progress. Bob 6 haven't touched. When you plan to touch? After SPM, is it? Okay, guys. I know it's quite tiring for you guys already. Okay, because I also very tired already. Okay, I need to get. Teacher, let me photo you here. Okay, come, guys. Remember, tag me with time. 6 a.m. 6 freaking a.m. until 9 a.m. Okay, guys. I hope this class at least help you all a bit before your exam. Okay, too fast. Okay. At least can pass. Hey, don't aim for pass lah. We all aim for A1. Okay. We put our expectation higher. Okay. Okay, guys. Thanks for coming for today's extra class. I hope you all can get whatever you are aiming for this coming exam. Okay. And let me know. Okay. What do you do in exam? Okay. How you do in exam? Okay. So guys, all the best for tomorrow exam. Okay. Today, finish this PDF. Thanks for the crazy class. Thank you, guys. Thanks for the crazy attendance also. Okay. Thank you, guys. Bye-bye. Bye-bye. 对的，没有 Chapter 7的 answer。OK，等下我发。你等下我 send。OK，拜拜。Post Chapter 7 tutorial. OK。I post. Okay, this video I will post after I convert already. Okay. Bye bye.